And grab a seat. Thank you very much. And we will start the meeting with our Pledge of Allegiance.
Wake up.
I pledge allegiance
To the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
And if that, you could do a roll call.
Bruce Popham.
Here.
Karen Thurman. Clint Barris.
Here.
Ken Yemeyer. Tracy Allen. Carolyn McLaughlin. Mimi Stafford.
Here.
Stephen Patton.
Here.
George Barrett. Rachel Bowman. David Makepeace.
Here.
Susie Rowland. Joe Weatherby. John Kincaid. Elena Rodriguez. Daniel Dawson.
Here.
Jessica Godfrey. Casey Fay. George Nugent. Heather Carruthers. Will Benson.
Here.
Steve Leopold.
Here.
Ben Daughtry. Vera Rauch. Justin Brulin. Jeff Kramer. Ken Rita.
Here.
Bruce Ferrer. David Vaughn. Shelley Kruger. Here. Jerry Lorenz. Corey Malcolm. Diane Silva. Andy Newman. Lisa Mangilia. Ed Barham.
Here.
Penny Blackburn. Phil Goodman.
Here.
Captain David Dupre.
Here.
John Hunt.
Here.
Daniel Clark. Joanna Walzak. Here. Christopher Kavanaugh.
Here.
Megan Johnson. Here. Honorable John Daniel. Honorable Michelle Coldiron. Honorable Norman Anderson. Honorable Deb Gillis. Honorable Craig Cates.
Thank you, Ben. So last night when I was reviewing our agenda, I wanted to interject something at this point and have Beth read our mission statement. I think it's very important to frame our meetings, beginning with this mission statement. I think it really kind of frames the reason why we're here. And so I think moving forward, at this point, we'll read the mission statement, and Beth, if you could have the honors.
The Florida Keys National Marine Sanctuary Advisory Council is an interactive liaison between the residents and visitors of the Florida Keys and the staff and management of the Florida Keys National Marine Sanctuary. In this role, and with the understanding that a healthy ecosystem is essential to the economy and quality of life in the Florida Keys, the Sanctuary Advisory Council will promote restoration and maintenance of biodiversity and ecological resiliency in the South Florida environment. We will strive to achieve a vibrant, ecologically sustainable ecosystem and economy through application of the best available science and balanced, conservation-based management.
Thank you. And if I can get an approval for the minutes of our January 19th meeting?
So moved.
Okay.
I'll make a motion.
Give me a second. Will Benson, thank you. And then we will adopt the agenda for this meeting. Any changes, edits, or updates to the agenda? If not, can I have a motion? Thanks again.
I'll second.
Thank you. Great, so just a quick few announcements before we get started this morning. For our Sanctuary Advisory Council recruitment, as you may recall, we recently had a recruitment for several Advisory Council seats that were open due to Advisory Council departures or term limits. The selection committee met a few weeks ago, and I understand that the selected applicant information has been forwarded to the Office of National Marine Sanctuaries for agency vetting. And as soon as we have the final selection, we'll let you know. New and/or returning members will be in place for our December 11th meeting. As you'll note on your agenda, the member and alternate working session this afternoon. We adjourned today at 2:20. However, that does not mean that the advisory council members and alternates are finished with our business. We will have a special working session from approximately 2:30 to 4:15 to flesh out an advisory council outreach and engagement plan. You will hear more about this effort this morning when we hear from Bruce about what the SAC core group has been up to. So please commit to staying for that afternoon working session. as a plan is really only as good as the information that goes into creating the plan, and all of you have something to contribute. We're going to be breaking up into little working groups, so we can kind of just get more information, kind of flesh it out a little more. If the public wants to attend, you're certainly welcome. It's not, you're welcome to attend, but it's just going to be a working session for a small group. So we don't want to let anybody think that you're excluded from this event. For public comment, it's a very important part of our meetings and the advisory council process. If you would like to make public comment, please sign up for the sheet outside on the information table. We only have one public comment period today, and that's at 2 o'clock. And then finally, we have 2 presenters who are participating remotely. So please be mindful of this when asking questions and wait for the microphone to do so. I'm now going to turn it over to Bruce, who will provide a brief update on the activities of the Sanctuary Advisory Council Core Group. Bruce.
I thought you were getting away without me, didn't you? Who's Beth, are you running the?
You have an advanced search if you'd like, or I can do it.
You don't mind what you
I
do?
don't mind.
So, core group, what's been 6 years now, 5 years? This group been around, we're getting aged, getting gray hair. We actually started the core group about 5, 6 years ago to kind of lead this entire process that we've been on, through the all the initial scoping that we did and all the meetings that Ken had with people from all over the county. And so it's been an evolutionary process. Now we're kind of getting down to where we're going to, the metal's going to hit the road here as the DEIS comes out, and we're trying to plan a strategy out to how we execute that, how we get that out to the public. So, go ahead, man. These are the members of the core group. It's evolved a little bit. There's been some changes. But it's pretty much the same folks, so it's been pretty consistent with the direction that we've been trying to go to and with. Go ahead, Beth. Let's look at our core objectives. See, that's what happens to me. I can click on the button. First of all, we wanted to get really key topics, and we wanted to get those distilled down to, hey, Andy. Hey, Bruce. We wanted to look for opportunities and mechanisms to really get the public engaged, and we went through everything we could possibly think of, and identify how each one of you can work together with us to try and reach out to the constituent group that you represent and to our community as a whole. So we're going to actively engage everybody to participate in this process. And as it says at the bottom, the process for the review for the recommendation on the DEIS, and then how we're going to do a format for both the public meetings and for the council to hear public comment, because I'm sure we will be getting some. So I'd like to review these 3 key messages. We've distilled this down. We have probably 5 or 6 of these, and we've got them down to 3. And we want to really kind of focus on these 3 messages. I'll give you a minute just to read these. I'm not going to read them to you. But underneath these, we will then develop some action, some additional thoughts to go along with them. So there's some key things here. We understand that this is part of our economy and our community. We've come up with this thought of a restoration blueprint, which is going to kind of what the DEIS is going to come out with. Is going to have some options. And I think that kind of gets a message across of kind of where we're trying to go with what's going on with the DEIS and where we're going to go with our management plan. And then lastly, just look at different opportunities we can get out to people in the community here. Now we're going to get into this a little more. So the first message is the natural resources we enjoy drive our economy and our communities and way of life. Here's some different things that we're going to provide underneath it. We're going to provide facts about the benefits of the resource. We're going to have facts about economics. We're going to have facts about achievements and success of the management team. We're going to include the bright spots and hopes for examples. And I'm sure there'll be some things that aren't so pretty, that we'll have to deal with. Next one is, as you see, is the restoration blueprint. And again, underneath that, Those messages are going to be the consequence of inaction, okay? What's at stake here? Acknowledge the importance and value of local knowledge. And I'll tell a local knowledge experience for myself. I had some friends that we had gone out to dinner one night, and it was a beautiful night, full moon. We decided to go take a boat ride, and one of the guests said, "You sure you know where you're going?" I said, "Yeah, know the local knowledge." Well, I had maybe 5 seconds after those words came out of my mouth, I ran around. So that's local knowledge. The decline in the resource condition, and highlight the importance of local engagement action, and then communicate the urgency of this action. Okay? So does everybody understand? Here's our key messages, and then the talking points underneath this, we're going to be fleshing these out with a lot of information for you to use. And the last one? Did we skip one?
No.
Oh, okay, sorry. I was slow there. The successful management of the Florida Keys National Sanctuary relies on our valued partnerships and community, and we're all part of the solution for the restoration blueprint. And we're going to emphasize the need to get everybody to continue to be have input, note that it's an inclusive process, and it's critical that we hear from the community. And that was part of our outreach program from the very start when we started talking about the management plan for the zoning process review, was to get out to the community, get feedback from the community. We've been doing that. Okay. Now, this is we're trying to define a list, and we've got an extensive spreadsheet. And when you look at this thing, we've tried to go through and identify every business and civic organization in the Keys. I mean, everything you think, Rotary clubs, community organizations, everything we can possibly think of. Look at the different areas the other different areas that we're going to need to deal with, which are local and national non-government organizations. In my case, things like the National Marine Manufacturers Association, and we can look at those type of other national organizations that we may want to have a say in this or want to know about it. Fishing organizations, diving organizations, boating organizations, academic and science community, local and state government, elected officials, media, schools. I mean, this is a pretty extensive list. It's going to cover a lot of places that we got to get to tell the message of what we're trying to accomplish here. The spreadsheet. And this is just a portion of it. And so you can see what we've done is we're trying to identify here different organizations, and then we're looking to put the appropriate SAC member with that organization, okay? And then have backups that go along with them, and then what the affiliation is, and then what the opportunities are when they have regular meetings, when we can get in front of these people. So and that's part of what we're going to do this afternoon. We break into groups. Is we're going to try and look at each one of these questions, and then look at how we can utilize your contacts and your input in the community to start getting this message out. So are we getting hooked up there?
Yeah, sorry about that.
That's all right. Timeline. This is, we're trying to be as...
Good morning.
Good morning.
Good morning.
We're trying to get out as far as we can. We're really planning out into next year, significantly into next year, probably into fall of next year. But at this point, what we're looking at really is what we're going to do from now through November and December. We only have one more meeting this year in December, and that's probably only going to be a half a day, probably. So we're not going to get a lot done there. Then we're going to be in February, and then on our schedule as we normally do every other month. So hopefully we can get as much of this kind of squared away and ready to launch when we get to December, so that we hit next year, we're ready to go out and hit the road and start getting this message out. We're thinking that DEIS, I don't want to jump out too far ahead here, Sarah, but I think we're looking at sometime spring, late spring, early summer. So we've got about 8 or 9 months here before we can do that. So, questions? Yes, sir.
Late spring, the documents will be ready to be viewed? Is that?
We're hoping that we can have it by late spring, early summer, Steve. It's got to go through the NOAA process and through our partners, the state of Florida and other people. So it's got to go through DEP and EPA and all that fun stuff. So that takes, and it's going to take some time.
You also have a new executive branch
You also have an executive branch coming in too.
So that's going to be a challenge for us at the state level to get that information out there. So, we have a lot to do. But we have a plan. And we have it pretty well structured. So, you up?
No, I'm just running my.
Questions?
Sir.
Any more questions? I did such a great job of presenting that.
Yeah. Great job.
Thank you, Steve.
Thank you. Thank you, Bruce. So the friendly reminder, the advisory council members and alternates are asked to stay for that working session meeting following the close of our public meeting. I remember some years ago I attended a management conference and we had a little breakout session where individually we were given a styrofoam cup and we had to write down how many things you could make out of a styrofoam cup. Then we all got together as a group and collaborated, and the results that we came up with were exponentially more than what individually we could do ourselves. And that's the point of this working group meeting this afternoon. Together, we're going to come up with more ideas than just individually or a smaller group. So thank you very much for your participation this afternoon. So moving on to our 9:30, sanctuary resources status 1 year after Hurricane Irma. It's really hard to believe where we were a year ago. Our October 2017 advisory council meeting was a special session focused on response, recovery, and resilience following Hurricane Irma. And while on the surface, it may look like the Florida Keys is recovered, but we all know we've got a long way to go. We will now hear brief updates about how the sanctuary resources have fared following Hurricane Irma. These updates will be followed by a brief question and answer for the presenters. Our speakers are Kara Radabau and John Hunt, both with FWC, and Jim Forkerin from FIU. I hope I didn't butcher your names. Thank you very much. We are also bringing in Kara via teleconference, so welcome, Kara.
Hi, can everyone hear me?
We certainly can.
And can you see the screen down there?
Yes.
Okay, perfect. All right, well, thanks for inviting me to talk about some of our research that we've learned monitoring damage and recovery in the mangroves at the Keys. So I want to thank everyone involved. This was a project initiated by the Coastal Lessons Group at FWC in St. Pete. And I am going to be referring to the mangrove species by name. So just so we're all on the same page, I'll briefly go over the three types of mangroves in Florida. So we have red, black, and white mangroves. The name comes from the color of the bark, not the color of the leaves or anything. So the red mangrove has reddish bark. It's most easily recognizable from the water because it has a really large crop root that provides stabilization. The black mangroves, they have pneumatophores, so specialized roots that stick up out of the ground that help them take up oxygen. So below ground in the mangrove forest, there is no oxygen. But the roots need oxygen for respiration, just like we need oxygen for respiration. So they stick up these pneumatophores or snorkel roots in order to acquire oxygen. This is going to be important later in the talk. And actually the prop roots on the red mangrove, they serve a similar function as well. They have little pores that take up oxygen for their rootstock as well. And then the white mangrove in the middle, this one has optional pneumatophores. So they can grow them if they need them, if they're in really saturated soil and they need to take up oxygen. So this study, we have been monitoring damage and recovery at sites in the lower Florida Keys, as well as in the 10,000 Islands. So our lower Florida Keys sites, and as well as the 10,000 Islands, they were all close enough to the path of Hurricane Irma that they received direct eyewall hits. So in those maps there, the red line, that's the center of the eyewall, but it was a really large eye. So all of these sites were impacted and received significant damage during the hurricane. So we visited all of these sites 3 times thus far. We started about 2 months after the hurricane last fall, and then our most recent visit was in June, so 9 months post-storm. And we're actually going to be down there again in a few weeks for another follow-up monitoring in the Keys. So some of the things that we've been seeing for canopy damage, I'm sure you have seen it all over in the Keys. It's not just the mangroves that were affected, but in all the trees. You see extensive damage with the removal of leaves and limbs and the canopy due to the high wind. Now the regrowth that you see, it varies by species. The black and the white mangroves, they can grow stems and leaves directly from their trunk. So this is called epicormic growth. So they have dormant buds beneath their bark that are capable of growing into leaves. So in a time of need where the tree loses its whole canopy, it can rapidly grow leaves in this way and start photosynthesizing again. So the trees have kind of this fuzzy appearance when they do this. And this is a unique mangrove. A lot of species of trees will do this. I'm sure you've seen that in the keys. The red mangroves, they do not have these dormant buds in the older trunks and branches, so you do not see this as much in the red mangroves, just in the black and the white. So we were fortunate enough to have visited these sites for another study before the hurricane hit. So we have some pre and post Irma photos of what the mangroves look like before and after the storm. Typically, a healthy mangrove forest, the canopy cover is around 85 to 100%, and that's what you see in the upper left picture. That's what a typical mangrove forest looks like. And then after the hurricane, we found that canopy cover was around an average of 40%. This did recover to about 60% within a few months as all that epicormic growth started growing on the trunk. But then it plateaued at 50%, and we haven't seen much recovery since then because it's going to rely on the much lower growth of the understory and the canopy. So it's really kind of plateaued for now, and it's going to take much longer for the rest of the canopy to fill in. So these graphs, they're showing data on our trees, and we're grouping together the trees by the stem diameter or the trunk diameter on the bottom of the graph. So the bars on the left, these are the smallest diameter trees. So in graph A, this is showing our tree species composition and the size of all the trees. So you can see that most of the trees are on the smaller end. They're between 5 and 10 centimeters in diameter. And then the larger trees, they become more rare. And most of our trees are also red mangroves at these sites, with occasional black and white mangroves towards the center of the island. In graph B, this is showing tree canopy damage. So all of the larger trees, they're sustaining really severe canopy damage. The smaller trees, they might get away with just low or moderate canopy damage. It's kind of a good thing to be a small tree in a hurricane. They can hide from some of the wind if they're shorter stature. But the larger trees sustain the most severe hits. And so in mortality, in graph C, the navy blue bars, that's showing mortality 2 to 3 months post-storm. So immediately after the storm, we didn't see much of a trend in mortality to tree size, but a lot of trees, even though they may survive the storm and even have some epicormic growth after the storm, they may die later on. So this is delayed mortality. So the light blue bar is what's showing the additional mortality that was added on 9 months post-storm. And we do see a trend in tree size for this delayed mortality, which is likely due to the fact that those larger trees had such severe damage to the canopy that was stressing the tree and it died later on after the storm. The other types of recovery in the forest, the understory is really important. There's often a lot of seedlings and it's the occasional sapling there that are just waiting to get a light source. So when the entire canopy gets blown out, then they have an enormous amount of light coming down, so the understory can really take off in these situations. So at a lot of sites, we've seen those established seedlings and saplings, they're shooting up and gaining height really rapidly. But not all sites look like this in the lower photo. Some sites have no seedling growth whatsoever. So what's going on in those sites actually has to do with another impact of the storm, and that is the storm surge deposit. So when the storm surge comes in, it's bringing suspended sediment from all the waves churning up sediment. It brings it into the forest, and then as the water recedes, it deposits the sediment in the forest. So this looks like a layer of gray carbonate mud. And it's easily recognizable in the forest, like the forest floor looks light gray instead of looking like its usual dark brownish red peat color. So this mud, it doesn't allow air to pass through it. So this is smothering the soil and it's smothering the roots. So if it's thick enough, it can block. I talked about the pneumatophores are designed to help the roots get oxygen, and the prop roots are also, they have these, in the lower left picture, the arrows are pointing at lenticels, those white dots. Those are respiratory pores. So that's where the tree can uptake oxygen and transfer it down into its roots below ground. If those get covered by mud, the tree essentially can't breathe. And this is enough to smother the tree and eventually cause death if the tree's roots can't get oxygen. And also in that photo to the left of the prop root, that's a pneumatophore that's covered in mud and probably not able to take up much oxygen either. So we saw in the areas that had these thick storm surge deposits, we saw a lot of delayed mortality as well. The graph to the right is separating our sites based upon how thick the storm deposit was. So minimal to no storm deposit, moderate, so up to a centimeter of storm deposit, and thick, so 1 to 9 centimeters of storm deposit. And these bars are showing how many trees are dying later after the storm. So 2 to 3 months post-storm mortality, and then jumps into 9 months post-storm mortality. And we're seeing big jumps in forests that have this thick storm surge deposit that's just smothering the roots, and the trees can't survive. Now, we don't want to give the storm surge deposit an entirely bad rap because it's also a good thing for a forest. And it can help the forest floor increase in elevation. And this is really important to helping forests keep pace with elevation, with sea level rise. And so historically, if you take a core really anywhere in a mangrove forest, you're going to see these bands of gray mud and see that, yes, this forest has survived hurricanes in the past, and you have these records of storm surge deposits in the past that you can see which storms it was impacted by. So it's not necessarily always a bad thing, but it can end up killing a significant amount of the trees when it occurs. Other storm impacts that we see, in some sites we do see significant coastal erosion. So it just depends on where the forest is located based on the angle of the waves when they were hitting the forest. So this used to be a mangrove forest. It is no longer. Now the elevation is too low for it to support mangrove trees. So this site, the mangrove died off due to erosion. And we also see, in some locations, there may be altered hydrology. So a lack of water can kill mangroves. Too much water can also kill mangroves. They like to be flooded at high tide and have their roots exposed at low tide. Because when they're covered by water, again, those roots can't take up oxygen. They're basically, it's like they're holding their breath when it's high tide, and they can only breathe again at low tide and take up oxygen. So in some cases, this is an example in Jensen Beach. Although I'm sure there are probably locations that happen in the Keys, but I think it's two kind of great examples. But this mangrove forest relied on just one location for the tide to flow in and out of the forest. This tidal creek was blocked by sediment during Irma. So water could only flow in at really high tide, and then it would just remain there and it couldn't get out at low tide because of this blockage. So all of that water in the forest will suffocate the roots. They can't pick up oxygen, and it causes a die-off in the forest. So this type of problem, it can be fixed. All you need to do is remove the blockage of what's preventing water flow. The other issues with mangrove forests often can't be fixed. You can't do much about the storm surge deposit. I mean, you really shouldn't try because it can be beneficial to the forest, and you don't really want to move mud around, as that can cause more damage than leaving it in place. But this is one thing that can be an easy fix if it's just a matter of clearing out a specific tidal creek or a specific mosquito ditch that's causing the impoundment. So, do all these mangrove forests recover? What is their fate after the storm? So, if they have appropriate elevation, hydrology, and a source of crop fuel, these are like the seeds of mangroves, they should recover. So, good signs in the forest, if you see living seedlings, like in this photograph, sure, the canopy is gone, but the seedlings are coming back, so that's a great sign. If you see no standing water at low tide, that's good. But you also want it to be flooded at high tide or just in the very high tide. But even if this situation does occur, it is a forest after all. So it's going to take a long time for the trees to fully recover that understorage growth, and it can take 10 to 15 years before that forest has recovered and matured. Bad signs. Standing water at low tide is a bad sign. No water at high tide or at very high spring tide. Not all forests are flooded at every high tide, but during the very high tides, they should have water in them. Complete mortality and no seedlings. That's a very bad sign. The lower right image, those are all seedlings that tried to grow, but then they died because that forest is constantly flooded. So forests that have really high mortality, they are at risk of peat collapse. So dead trees are not growing roots. But below ground, there is still a low amount of decomposition going on. So as the ground decomposes and there's no roots to replace that mass, the ground can sink a few centimeters. And often a few centimeters is all it takes for that forest to be at the wrong elevation for mangroves. And so it makes it even harder for the forest to recover. So what happens in these forests that are not recovering? They can turn into mudflats. So this is an image from Everglades. One on the left is from 1928, before a hurricane. A Category 5 hurricane hit in 1935. So the photo on the right is about 20 years after the hurricane. And you can see all those open areas, especially the ones with the black arrows pointing at them. These are all mud flats where the trees did not recover. So this is a possible fate to some sites. If you see no regrowth whatsoever, it's possible they may turn into a mud flat. So in summary, types of damage that we're seeing, there's wind damage to the canopy, storm surge deposits can kill the trees, but not necessarily a bad thing because it helps to increase the elevation of the forest. Some sites do have significant erosion, and some sites do have altered hydrology as well. So types of recovery that we see, the hydroponic growth is important on the blacks and the whites. Help out with canopy recovery. Understory growth is key, and then if it doesn't recover, you may have a mangrove die-off conversion to mudflat. So thank you to our funding sources, to National Fish and Wildlife Foundation, and to NSF, and to the small armies that made this all possible. And with that, I can take any questions.
How do you want to do this?
Yeah. You want to take questions now, Beth, or should we wait till the end of the three? Yeah, let's wait till the end. Yeah. So, John, please.
Give me a second.
So good morning, everyone. So I'm going to, talk about nearshore sponges, both from our nursery perspective and from a natural habitat perspective, and try to get through it in just a few minutes. So we've spoken about the nursery work to the SAC before, and so this will just be a little bit of quick review on that topic. And I don't have the...
Oh, do you want it or do you want it here?
Oh, I don't know. What do I?
Just
advance there.
So it's important to remember for sponges, Irma was just the most recent event that has impacted sponges on the bayside primarily of the Florida Keys. And we're talking really about bayside sponges. There have been all the series of cyanobacterial blooms that we've discussed over the years in this room or other rooms that each time they show up in a high enough concentration cause a sponge die-off. And so the sponge community has been in this constant state of large impact and then slow change. And in fact, I'll echo, Cara said, mangroves, 15 years to recover. We contracted John Steedley, who sampled for many years after the sponge die-offs that occurred in the early 90s, late 80s, or early 90s, and that recovery to a more or less full sponge community with all the diversity and size was 15 years. So that, I think it's just a coincidence, but it was the same. Nevertheless, all of those events inspired efforts to restore the community structure. And so we have had research colleagues. Mark Butler has done a fair amount of science on the topic, and we stepped up to the plate to try to expand that in partnership with the Nature Conservancy, Bonefish and Tarpon Trust, and Florida Keys Environmental Fund, supporting us to scale up. So we set up these nurseries in the nearshore waters, and we set them up because these were locations that had been unimpacted by the cyanobacterial blooms. So that was our thought process. Little did we know Irma was on her way. Quick on the propagation process. You go to, is there a,
Maybe.
oh well. So you go to a sponge, you cut it off, you cut it up, we put them on these pavers, and in due time they will grow on the paver, and then ultimately they can be either cut up again, just the same way we do corals, or outplanted into the shallow waters. As of May 2017, we had 8,000 cuttings in our nurseries. These are not all the species, but most of the species that we had in our nursery. And then Hurricane Irma hit, and so what you can see was the impact of Irma in our nurseries. And so our survival rate as of June 2017 was 84%, and our survival rate on average was, after Irma, had dropped to 40%. So we lost 40% or so of our sponges from the impact of Hurricane Irma. And especially at our Burnt Point nursery. And our Burnt Point is there across the highway from Curry Hammock State Park. It's that long strip of land that used to be the Stanley Switlick House, for those of you who have lived here for a long time. I don't know who owns it now.
The Bush Mansion.
The Bush Mansion, that's right, the Bush Mansion. And of course, Switlick Elementary, all that stuff. And Burnt Point, it turns out, was our most shallow spot and our most prone to sedimentation spot. And that is why the impact occurred primarily at Burnt Point, because Florida Bay, in contrast to a storm surge, the water left Florida Bay for quite a long time. So just from a sponge nursery perspective, we abandoned that nursery. We've added one in Long Key Bight, and we have been working hard this past year to recover our nurseries. And we started propagating last winter after my staff was kind of ready to get back to work. and we're back up to 5,000, and we are just gearing up right now to continue to add to our nurseries. So now let's jump to the natural sponge community, and I'm going to focus inside this little box. That box is about 20 hectares in size. It's on the east side of Burnt Point. Your site is kind of within the box.
I was wondering.
Your site's within the box. I mean, we're not, I mean, we could put, we could.
What are you doing with this?
So we are taking sponges and putting them on some of your live rock, and we've been moving your live rock to other places. You're fine with that, right?
Yeah, got it.
And that star was our nursery. And so these are photographs from that area that we didn't take, but in general, that was kind of a pre-Irma sense of that general area. And we have done sponge biomass estimation in that area pre-Irma. And so let me come back to this a little bit. I asked Bill Sharp this morning to give me more of a numeric sense. And on average in that area, in that 20 hectare area, on average there are 7,000 sponges per hectare. So you take that box and take that 7,000 and multiply it by 20, and that's how many sponges are in that area. So we're talking about 140,000 sponges. And so in a very small area. So that gives you a sense of what we have always considered to be a robust sponge community. And why is Burnt Point a robust sponge community or a robust hard-bottom community? Well, I'm fairly confident that is the spot at which the currents that come along shore from Vaca Cut and the currents that come along shore from Tom's Harbor kind of meet and converge. And so that's where everything drops out. And I know this from past highly technical science studies that we've done. They were our grapefruit studies. And so we put grapefruits in Vaca Cut and Tom's Harbor back in the 80s, and then sat on university boats, because you can do things on university boats that you can't do on state boats. Captain Dupree, you would not know what that is. And we would actually just floated with the grapefruits and stayed behind the grapefruits. And they all, they went a lot of places, but a large portion of them ended up right at Burnt Point. And it is a very, very, take away Irma, has been a very lush hard-bottom community.
There's your science folks.
There's science in
There's
it.
your science folks.
And I remember it. So this is post-Irma. Yes, you still see sponges, but these sponges, note it's just a skeleton instead of, the dark brown color of a loggerhead sponge. These sponges are dead, they just haven't decomposed. So this is the biomass story in that area put in a bar graph. And so essentially that area lost about 90% of its biomass. And it's the only area that we've worked on. We haven't done a major survey up and down the Keys. And these are just a couple of photographs from Key Largo that show how the water went out. And you can see all of these little dots here are all sponges, probably loggerhead sponges, but all sponges sitting in the air. We have similar photographs, and you can see them up close up here and those small dots, where the boat that was anchored is now leaning. We have photographs in the Alamorada area. We have a video of a woman who lived on the water in the Marathon area during the hurricane in her video, trying to show through her screen, she couldn't see through, that the water had gone out. So pretty much, we know the water at least went out in Hurricane Irma from Key Largo to the Marathon area, and in those shallow waters has caused the mortality of sponges in the nearshore shallow waters. So what is our plan? So we're going to take this to be a research area, go to that east side, and beginning next year, try to restore one of those 20 hectares. This says 5,000, our goal is back to that 7,000 per hectare density. And then try to see if by doing that, it will jumpstart some natural recovery in the area. And then we'll be going to a few other locations in partnership with Mark and a few others who have submitted a grant proposal related to this. And so that is the sponge story. Absent restoration, 15 years. With restoration, I don't know, but let's think about our capacity. There are billions of sponges that died in Florida Bay from this. So there's the sponge story.
Thank you, John. We'll continue with the seagrass and water quality presentation with Jim Forkred.
Does the pointer work?
I didn't figure that out.
Yes.
Hi, thanks for inviting me to come and speak to you about water quality and seagrass issues within the sanctuary. I hope that everyone knows, sorry, closer. It buzzes when you do that, you don't hear me? I hope that you all on the council know that the act that created the Florida Keys National Marine Sanctuary also created a water quality protection program that designed in the early 90s a rather robust spatially distributed monitoring program for looking at water quality in seagrasses and corals. And so because of that, we've been looking for a long time, and we have good data to compare things to. Today, I'm going to talk about Penny Hall and Brad Furman's Florida Bay data. Sarah Wilson is now my lab manager, who's just written a manuscript that describes the seagrass story I'm going to tell you. There's a special issue of the journal Estuaries and Coasts that's put together science papers about the impact of Hurricane Irma that hopefully will be out this time next year. And then Chris Madden from the Water Management District sent me some water quality slides for what happened to the water quality in Florida Bay when all the water ran out and then came back in again with all the wind and stuff as well. So these are Chris's data, and the colors, this is kind of clipped off the top, but this is the amount of plankton in the water column. There's basically cyanobacterial blooms, and blue is clear water. So right before the storm, there was an algae bloom going on up in Seven Palm Lake, but across most of Florida Bay, there was very little algae, despite the fact that we had the seagrass die-off and the algae blooms fueled by that back in 2015. Contrast that to the next month right after Irma, there's really high, these are almost unbelievably high chlorophyll concentrations. The typical, so this runs from 0, the yellows are 15 to 20. When I used to run this program, if I ever saw greater than 0.5, I thought that was a bad algae bloom. So there was a lot of stuff in the water column. And that slowly relaxed. So this was in June. And I'll show you the time series. And hopefully remember to say something about how long it takes seagrass to recover after die-off. So this is basically, this is 2015 water year, 16, 17, 18 water year. we had the second recurrence of the seagrass die-off event, likely in response to hot, salty, low oxygen water, probably exacerbated by water management, where we lost lots of seagrass in many of the same places that we lost it in the 1980s, in the late 1980s. Penny Hall's data, I'll show their monitoring program here in a second. That program was instituted following the 1980s seagrass die-off event, and we know from her data that it takes about 25 years for the seagrasses in Florida Bay to just get back to what they were before the die-off event, and that was the year we had another die-off event. So the good part of this story is, this is chlorophyll, this blue line, right? And after the hurricane, we had these big algae blooms, but it's calmed down. The trajectory seems to be heading back to normal back in Florida Bay, both for chlorophyll A and for the phosphorus that drives that phytoplankton bloom. So current trend shows improvement, but all of you with local knowledge know that there's still algae blooms floating around out on the bay side. I'm not going to present data from the rest of the sanctuary because I was supposed to call somebody and get it and I didn't. But it's the same general story. There were measurable impacts directly after the storm that basically it looks now like it has over the last 25 years. Okay, so the sanctuary through the EPA, the Water Quality Monitoring Protection Program since 1995, has funded observations at all those blue dots about what's going on with seagrasses. Then we do the same thing out in the dry tortugas, and these red dots are places very close to shore that were added about 5 years ago. We've been swimming those sites since this guy was a graduate student, and he's now the director of the Office of Coastal Zone Management in North Carolina. So, as you know, seagrasses live underwater, and it's often difficult to see through the water to know what's there. There is no good way to do remote sensing on seagrasses in the kinds of waters that we have around here, so we put people in the water and we swim 50-meter transects. And we record not just what's the seagrasses that are there, but this is, you can't see it from where you're sitting, but that's basically an algae guide. This was a young, we've taken many undergraduates out. This is a young woman from University of Hawaii that was participating in our REU-funded program, and we got her out there this summer. And she actually got to do some of the surveys right before the hurricane. And what we do is we put these little quadrats down on the bottom. They're this big by this big, and we look at the density of grass within them, and we have some iron spikes driven in the ground, so we can basically relocate exactly our points of observation. So just before, well, a couple months before Irma, this site looked like this, and this is mainly turtle grass. And then right after it looked like that. And well, I'll talk to you about what's driving that. Some places are buried, and some places are eroded, depending where they are with respect to the storm. So more sites. We know that lots of stuff got buried. So let me show you the network of sampling sites. It's not just the ones that I just showed you, because none of those were in Florida Bay, but back in Florida Bay there are a number of programs. So you see these blue patches. Those blue patches are places that the FWC lab, Penny Hall's lab, and Brad Furman go twice a year, and they randomly sample 30 places within each of those blue hexagons. And then these orange spots are a combination of our LTER program and the FWC program, and those are permanent transects that get swung. And then we've got all of these sites that are distributed. Now, the colors are just the zones of the sanctuary as set forth by Orlando and Klein when we were scoping out the original management plan for the sanctuary. But they provide us with an easy way to group the data. So we can ask is there a spatially coherent pattern being driven by the hurricane? So we can say within, say, this purple box, was there an average loss of seagrass or not? All right, so these plots, this is the seagrass side and this is the macroalgae side, show just the raw data in the fractional loss of above ground seagrass on this side and macroalgae on that side. The reds, that's 75 to 100% was lost between sampling just before Irma and sampling just after Irma. So you see that there's a kind of spatial pattern. There are sites in the lower keys that really had the larger fractional loss of seagrass. And then, despite the fact that Florida Bay emptied out and it's real shallow, there were very few places that showed less seagrass the month after Irma than there was a couple months before Irma. Now, part of that is because seagrasses have a seasonal pattern. And there's a peak in biomass here right around September, and then there's a loss of biomass. About 50% of the leaves are lost over the next couple of months. So this hurricane hit right at the same time there would have been a natural loss of leaves. So we've asked the question then, if you take that seasonality out, where were the losses of seagrass biomass greater than you would expect just because of that seasonal thinning? And basically that says this place, the backcountry in the lower keys, there was pretty much uniform loss, much larger loss of seagrass biomass than you would expect. And then even though there were spots within the rest of these zones that had pretty severe storm impacts, they were really isolated to those spots. So it wasn't, everywhere across the system. Now, since the first report I know was in 1960 of people going out to the beach after Hurricane Donna and seeing seagrass piles this high all around Biscayne Bay, and they made the assumption that, wow, there must be no seagrass left. And we saw the same thing in following Irma. There were pictures in the Miami Herald of huge racks of floating seagrass out there. So once again, people thought, well, maybe there's no seagrass left. But really, there was no change really in the spatial distribution of seagrasses. There was just a lot of removal of leaf material. And in most places, the growing parts of the plants are still there. All right, so this is one way of looking at it. You see that this regional negative change, that was largely due to erosion and deposition. And then these guys up here, these upper basins, was a secondary water quality loss of seagrasses that were caused by both the dumping of fresh water out of the system before the storm, and then the increase in turbidity and the tremendous amount of runoff after the storm. It basically took places that had been marine basins and turned them into really turbid lakes. So we lost seagrass for the secondary reason up there. So just another way of looking at the same data using a different statistical technique. Where were the losses significant? Well, just the same red spots. So to show you what that looks like, these are the data running back to 1995. And you see that there's kind of an annual up and down. And then there's some places where, so this is the data pooled for that entire Lower Keys backcountry area. And if we do that, there's a seasonal signal. And we can write a pretty kind of a simple equation to predict how much seagrass there should be as a function of time of year given the seasonality. And so this green band is, if it falls outside of that green band, you're 99% sure that that's greater, that's a deviation from the long-term pattern. So this is the number then for that the Lower Keys backcountry. There's a significant decrease in seagrass biomass even when you compare it to the seasonality. So underwater, this is kind of what it looks like. This is a site, 255, so that's Oceanside, Marathon. And there was quite a bit of sediment that moved out through the passes and buried seagrasses. And then that was 10 centimeters, like that much sediment. Moderate, this is site 239, which is even further to the south. This one got buried. And then we had 276, which is Oceanside, Key West. There was removal of about 10 centimeters of sediment, but because the plants are rooted, all of the roots were still there. And then this last one, I think the next slide shows a little bit better. Sediment used to be this deep on all of these things, and now it's down almost 15 centimeters. So a lot of mud moved around out there. So let's compare this. Remember, we've had these sites in place for a really long time. And many of the sites that were devastated by George back in 97 or 98 were also hit by Irma. And in fact, the pattern of the impact of the seagrasses that we found in the last few months looks a whole lot like a paper we wrote in 2000 after the passage of George. And so this site 216, this is Carey's Fort Reef, but off the back of Carey's Fort. There had been a pretty nice dense seagrass meadow that George removed, and it eroded the whole thing. And so that stayed no seagrass until 2012, and we just started getting the seagrass community back. Now Irma has taken that one out and eroded that one out again. On the other hand, this 243 site just off here, off the Long Key, it had been a moderately dense seagrass meadow. It was buried, and then it came back and was buried many times, and now it's been buried again. So that is a very dynamic site. You would be hard pressed if you went there in 2003 to see if it was any different than before George. But this site obviously was way different than it was before George. And then this site 309, this is in the backcountry north of Key West. It was a very dense turtlegrass meadow. George took it out, and it's just never come back. It's basically stayed bare sand with occasional little blips of macroalgae. So I think that's the last slide I have. Yeah. So the story, the hurricane caused ephemeral water quality impacts that have largely subsided. And if you look at our fixed stations, there have been a few places that have lost seagrass, and many of those are in the same places that we saw lost in George, largely because George and Irma had almost the same track across the Keys, if you remember. Now, I'm sure we had a comment about local knowledge earlier. I'm sure all of you know a place, if you've been out on the reef, where there was a grass patch and there isn't a grass patch now. Right? And our data are not picking those kind of movements up because we're at fixed sites. So we know there was erosion, we know there was deposition, but at the landscape scale, those are within the noise that we see in general within the system. Thanks.
Thank you, Jim. All right, thank you for all of your perspectives, the known information about the resource status. I'll open it now for the advisory council discussion and question and answer. Just please be cognizant that we do have somebody on teleconference, so wait for the microphone before you ask your question, please. Thank you, Andy.
Thank you. Okay, thank you. So this is a question about mangroves. So for a person on the phone there. One thing I noticed a couple months up in the Alamorada area, specifically Lower Manacumbi Key, there's a small channel between mangroves called, affectionately known as the ditch. And I've always been curious as to why one side of the mangroves look perfectly healthy, and the other side of the, one side of the little channel. I'm talking about a channel that's, I don't know, 75 to 100 foot wide, maybe. And then the other side, like all those mangroves, just like seemingly dead as a doornail. I was just wondering if anybody had any answer on that.
I'm not familiar with that specific location, but one of the most common causes of local die-offs like that is poor hydrology. So if water can't get out at low tide, that's the most common issue. So there might be something that is blocking tidal flow, that it can't flow in at high tide and flow out at low tide, and those can cause really location-specific die-off.
It's such a narrow channel, though. It's strange. I think something worth looking at.
Yeah, it would be interesting to see the location either through satellite imagery or in person, but it's hard to tell without seeing the location.
Yeah, question for John. I know it refers to some type of unit of measurement, but what would the approximate dimensions or the term hectare? What is that equate to? Is that
2.2 acres. Yeah.
There you go, 2 acres.
2.47.
About two.
About two.
We looked at that.
It's 100 meters by 100 meters. So if you think of a football field.
So, yes,
Well, that's much easier.
it's 100 meters by 100 meters, so 2.5 acres.
Who else got a question? Dave? Oh, sorry. I'm sorry, Dave, go ahead.
Hey, John, it's actually for you again. You went from 80% to 40% survival rate on the sponges that you guys are putting on pavers. Do you have a percentage of that which was just maybe buried up or died versus rolled over and got washed away? Or was it significant?
So at the sites near shore, meaning on the backside of the islands, those pavers and sponges did not move. And so that would all have been the exposure to the air and then mortality. At the Sand Key site out kind of in the edge of the wildlife refuge, is just inside the refuge, they got moved around and jumbled around, and we had a few disappear, but most of them were there, and if they stayed below the water surface, they were alive.
Just from my perspective, I stayed on Stirrup Key at that time, and we saw dry land behind Dynasty Marine there on Stirrup Key all the way out past the island there. And it was, I mean, for a couple of hours, it was dry land back there. And then also in Georges, we had a live rock site on the ocean side and lost all of it, just got washed away. So.
And that Stirrup Key story, that's one of our sites, is right in that area.
Yeah, I have a mangrove-related question. In the sites where you're getting appropriate flooding in high tide and drainage in low tide, so that the hydrology is good, is there any consideration of any kind of restoration effort for those areas? If they're not getting propagule recruitment, is there any thought of just going in there and dropping a few propagules in and see if you can jumpstart things?
So part of it might be the timing of the hurricane, and if that site has seedlings already. The red propagules are the ones that we see the most common turning into seedlings, because at the time the hurricane hit, that was right when the black trees and the white trees were releasing their propagules, and they just got blown away in the wind and washed away in the storm surge before they could take root. So it's around that time of year again, so if you're not seeing any propagules at all, then that might be a consideration, or it might be that that area in fact doesn't have the proper elevation or hydrology, because mangroves, they're quite good at self-feeding themselves without being planted. Oftentimes for restoration efforts, it's just you restore the elevation and the hydrology, and maybe plant some marsh grasses to keep things from eroding, and then you just let the mangroves plant themselves. So they are quite good at self-feeding. So a lot of restoration efforts just focus direct, and then letting the mangroves find their own way.
Thank you.
Susie?
Hi, this question is also for Kara. I was curious if you had noticed a change in the rate of growth or the growth rate of especially the red mangrove lately with higher water levels that I've been noticing in the bay and the backcountry, and if ultimately the sediment deposits could be beneficial in the long run for them to keep up.
Yes, in the long run, they normally are beneficial. There is the exception if the forest is so stressed it turns into a mudflat. That's the exception. But in most forests, as long as you see some early signs of recovery, it's good in the long run. In terms of growth rates, it's kind of a thing grow slowly at first, and then it more rapidly takes off as the trees get larger or they've had a longer time to recover since the storm. So recovery can be quite slow at first, but as long as you're seeing green on the trees, that's a good sign. It's not going to be a rapid recovery at first.
Hey, Kara, this is Jim Corcoran. Let me add on to your response to that question. We know that the southern mainland of Florida is really, really phosphorus limited. And the phosphorus that supplies those trees, the reason the trees are so small is because there's no phosphorus there, really. Hurricane Wilma put about 30 years worth of phosphorus input in that fine sediment up into those forests, and we measured an increase in productivity because of the moving of that sediment. So I think the answer is sometimes it's good and sometimes it's bad depending on the geomorphological setting and whether phosphorus is really limiting, which doesn't seem to be the case on the mainland.
I wanted to kind of clarify in general. I was sort of asking about rate of growth of the red mangrove, just in general, even without the catastrophic storm, in response to sea level rise.
I have a question.
The rate of growth in response to sea level rise?
Yes. Yes.
It's, oh, yes.
Yes.
Okay. Well, in general, what we look at in the mangroves is we're looking at rate of accretion of the sediment. So how fast are they adding millimeters of peat to the basis of the forest compared to how fast is sea level rising in millimeters. And so we compare those two rates. So currently, it varies by location. But in many locations, mangroves are currently keeping pace with the current levels of sea level rise. But the concern is that as sea level rises faster, mangroves are going to have to accrete that peat faster, which is a direct correlation of growth, of how much roots they're putting out underground. So the concern is, can they grow faster and put out more roots in response to sea level rise? And some studies show that they do increase the rate that they're increasing their elevation in response to sea level rise, but some studies show that it's not enough. So that's really an open field of study right there, is can the forest keep its own location and increase its own elevation enough that it can remain in that location when sea levels rise.
I have a question for John Burns about the sponges. Are there certain species that have a greater survival rate than others?
I don't think so, but I'll have to actually ask Bill that question and get back to you, because he would know those details.
Okay, I'm just wondering if some species were more impacted either by, agitation or buried.
Yeah. Well, nothing was buried.
Okay.
But I don't, and it wasn't the agitation, it was the exposure to the air that was the issue. So I'll have to check with Bill, but I don't think so.
Okay, thank you.
John, I have a question for you too.
Oh.
When you were doing your grapefruit study, did you think about taking vodka with you so you could make something else?
it's possible that there were thoughts of that nature on those university votes.
But you're not saying.
But I'm not saying. So I also have a question now, so that's why this was here, and it's for Jim. Jim, what's the source of the phosphorus that drove the blooms from the hurricanes? Was it those accumulation of sediments or what?
John, I haven't done the budgetary analysis. My sense, though, my seat of the pants guess is it was the mixing up of the unconsolidated sediments, because that's where there's more phosphorus. It's difficult to get fresh water in runoff coming across the Florida Everglades that have a whole lot of phosphorus in it. So my guess is that it was internal loading caused by the resuspension of all the sediments.
Any other questions? Well, thank you all very, very much for those presentations. Sobering, it's great information. We are a little early for our break. Let's go ahead and take a 20-minute break. We'll come back at 10:35.
So what is
Thank you. As I'm sure we're all too well aware, the coral disease event remains ongoing and is a priority for the sanctuary and many of the partners in this room. Andy Bruckner, Florida Keys National Marine Sanctuary Research Coordinator, will provide an update on behalf of the many partners engaged in researching and responding to this event. Andrew?
Microphone. Sure.
Oh, microphone.
Good morning, everyone. Thank you for this opportunity to talk a little bit about this coral disease outbreak and some of the recent advances that we've made both in understanding and beginning to address the disease. I would just like to start out by mentioning that this is a multi-agency effort involving both federal government, state agencies, academic institutions, non-government organizations. It's a really large group that's come together to respond to this event. And so what I'm going to present is really on behalf of all of our partners. And let's see.
Can you go on that side?
Yes. Okay, so what I want to do is I want to first present a very brief overview of a lot of information that you've probably heard before, what we really know about some of the facts on the occurrence of this disease in the water and what sort of impacts it's had, a little bit on some of the potential causes of the disease, but really the main emphasis of this presentation is to talk about how all of our partners are responding to this event. I'll talk about some of the partners that are involved and some of the different activities that we're undertaking to respond to the coral disease outbreak. So you've all probably seen this, and I'm not sure why they're getting cut off at the top. Maybe it doesn't really matter. You've probably all seen these images. This shows the spread of this disease over time, and as you've all heard before, the disease first appeared off Virginia Key around the Miami area, and it slowly spread both north and south. By 2015, the disease spread through Broward County. It continued through Biscayne National Park. 2016, it reached up into Palm Beach County. It first appeared in the Upper Keys. By 2017, it had moved all the way through the Upper Keys into the beginning of the Middle Keys, and it reached the northernmost extent of the Florida Reef Tract near Martin County. One of the things that's really, really unusual about this disease compared to all other coral diseases that we've seen around the world is the large number of different species that it affects. There are at least 22 different taxa of corals that are being hit by this particular disease. It includes many of the really important frame-building corals, a large number of species that are listed on the Endangered Species Act, as well as some of the other rare species of corals. And one of the other really unusual things about this disease is once this disease moves into a certain reef, what the high proportion of colonies that become affected by this disease. What this shows is, I don't know why these are all cut off, but this is monitoring information from surveys, the CRENT surveys, or the Coral Reef Ecosystem Monitoring Program that's done by FWC, and it shows the percent of corals within the Upper Keys sites. There's 14 different locations that they look at every year. How much disease was seen on some of the key species that are affected by this disease during each annual monitoring program. And what I want you to notice is from 2011 to 2016, the overall proportion of corals on these reefs that's affected by disease is relatively low. This is sort of what we call background levels, normal levels. But then suddenly in 2017, when it got into these sites, we had dramatic increases in the percent of corals that were affected. These diseases there's a number of diseases that are affecting reefs. There's about 8 different key diseases that you see throughout the wider Caribbean and Florida that have been known since the 1970s and 1980s. This reflects primarily this stony coral tissue loss disease, and you can see that in some species up to 50% of the colonies were affected. One of the really important things about this as well is this is only a single time point. So when they did these surveys, they saw a very large proportion of these corals affected, but this disease continues to spread around. And I'm going to show you another figure in a second about how that disease has spread. So there's a lot of different theories about what the causes of this disease are, as well as some of what we call enabling factors, things that may be responsible for the disease. When we look at other coral diseases that have occurred around the world, there's a lot of them that have been associated with coastal activities, things like dredging projects. The dredging may stir up the sediment and release some sort of pathogenic organism that's present there. It may just degrade the water quality, increase nutrients. It may just cause a lower visibility that really stresses the coral out and makes them more susceptible to other pathogens. Within the Florida reef system, from those figures that you showed before, the disease spread both to the north and to the south. And we believe that it's a waterborne pathogen that's responsible for this disease. And so one of the things that's going to affect the occurrence of this disease is the normal Florida current that flows up to the north. However, it can also move to the south because, as everyone that's been out diving or fishing knows, that there are currents that also go in the other directions, and we have a number of these eddies, and so these can be one thing that can transmit a pathogen through this reef system. One of the other factors that we started seeing as a trigger for a lot of coral diseases throughout the Caribbean is perturbations in water temperature, both cold water events and warm water events. The first time this was really noted was from the Eastern Caribbean. During 2005, there was a really severe coral bleaching event, and as the corals began to recover from that event, they then suddenly showed signs of disease, and in parts of the Eastern Caribbean, it caused losses of 40 to 50% of some of the large boulder corals. Well, we had a very unusual cold water event. Actually, this is the coldest water that we've seen since we've been measuring water over the last 30 or 40 years in 2010. And then 2014 and 15, we had water temperatures that were higher than what were recorded previously, and we had this mass bleaching event. So that could be one of the factors that caused the corals to have a lower resistance to some of these pathogens, and it may have triggered this infection. The other thing that we've seen in other locations is when there are some of these other acute events, such as hurricanes, that can also trigger outbreaks of coral disease. In particular, if there's a pathogen that's trapped in the sediment and you get a storm that moves through an area, it can resuspend that sediment, and whatever microorganism, bacteria, or other organism can get pushed up into the water column, and then that can land on the corals and cause disease. The other important point about hurricanes is typically when you have hurricanes that are associated with very low visibility, a lot of sedimentation in the water, and all of those things are factors that can stress these corals and make them more susceptible to pathogens. But those are just some of the possible enabling factors that may be associated with it. To date, we really don't know what caused the disease. And one of the things that we did since the last Sanctuary Advisory Council meeting is we held a coral disease workshop in Key Largo, Florida. This was an update from a workshop that was held in 2017 that was really the first step to start looking at how can we better respond to this event. And one of the outcomes of this coral disease workshop was to create a whole series of different response teams looking at very specific aspects of this coral disease to better understand the disease and to start developing different actions that we can take to try to mitigate the impacts of the disease. And I'm going to talk briefly about 7 of these response teams that we've put together. And first I'd like to just mention again that this is a multi-agency effort. This just shows not all, but most of the partners that have been involved to date, and we keep adding new partners. There are about 45 different federal, state, non-government, academic, industry representatives that are all participating in this effort. And this is a really, really important thing to mention. One of the things when I first came to the Florida Keys, the first thing that I did was actually look at what had been done. And I've worked on coral diseases and other things around the world, and I've never seen such a large response to some particular event. Everyone has really come together and is working side by side to better understand this. Coral diseases have been known to affect reefs for the last 30 years anyways, but typically what's happened is a disease has moved into an area, it's wiped out a lot of corals, and it's moved on, and we've done nothing. And so this is really the first time around the world that there has been such a large collaborative effort to address this disease. So as I mentioned, I'm going to go through some of the these main response teams that we've put together and talk about some of the actions that we have done to date. And so the first one I'm going to just briefly mention is the Research and Epidemiology team. And largely since the last presentation that you had on coral disease at the Sanctuary Advisory Council meeting, we've learned a lot more about what's going on in the water. We've done much more detailed work on tracking how this disease is spreading, what sort of impacts it's having, and there's been quite a bit of work on some of the potential causes. So one of the things that we did, which is relevant to a lot of our activities, is we looked at where this disease is, and we've been able to separate what we call zones, or different areas within the reef tract, based on when that disease first appeared. And this is really relevant to a lot of the actions that I'm going to talk about that we're undertaking. And so we can split this into areas that we call the endemic area. These are places that were hit by this disease 1 to 4 years ago, and so really the Upper Keys all the way up to Martin County are the areas that were first affected. We then have areas that are right in the center of the outbreak. These are what we call the epidemic areas, the areas that have the highest prevalence of this disease. And so now it's actually about halfway down the Middle Keys into some of the Lower Keys. Then we have what we call the invasion zone, and these are the places where the disease first appears in an area. When we start seeing the first signs of corals affected by this disease and it starts to spread, but we're not yet at this level where we have such a high prevalence of disease. And then, again, I'm sorry these are cut off, but the area that hasn't been affected would be our pre-invasion zone. So one of the things that we've been doing is really tracking where this disease is. We need to know where it is in the reef system, how it's continuing to spread, so that we can direct some of our intervention activities. And what we were hoping wouldn't happen was that we hoped that the disease wouldn't move past the Middle Keys, because there's that long expanse of really not a lot of reef habitat around the 7 Mile Bridge area. But in April of this past year, disease was first observed in Looe Key Reef. It has continued to affect that area, and that area still really has a very, very high prevalence of disease. It's continued to move west, but it's really, really slowed down. Between 2014 and 2017, the disease was spreading an estimated 7 to 10 miles per month. It's really slowed down to only maybe 1 or 2 miles, and actually since April, it has only moved about 5 miles to the west of Luke Key. It hasn't quite hit American Shoal yet. And the other really important thing is right now, the highest prevalence of disease is really on the outer reef system. It hasn't affected in the lower Keys the reefs that are on the mid-shelf or inner locations. So one of the other things that we've learned is that we are able to divide the species that are being affected by this disease into what we're calling early susceptible species and intermediate susceptible species. Typically, when the disease first invades a reef, there are certain corals that get hit first. And what's really unusual about this is it tends to hit these corals that are, there's 3 or 4 species that are in the family Meandrinidae or whatever. There's certain brain coral type species, the elliptical star coral and pillar coral, that tend to get hit first. And then within a few weeks, it starts to hit a lot of the other brain corals. These are the corals that tend to show the highest overall prevalence. They're the ones that show the greatest rate of tissue loss, and a lot of these tend to be eliminated rather quickly. Some of these are smaller corals, but it includes some of the brain corals that can be several meters in diameter. We then have this other whole group of corals which are really the primary frame builders, like the star coral colonies. There's the mountainous star coral, there's the lobate star coral, and the third species of star coral. These 3 are listed on the Endangered Species Act. These are actually the most important corals in terms of building the reef framework throughout the Florida Keys. And then there's things like starlet coral, the large cup star coral. I'm not sure what Stephanocinius common name is, sorry. But anyways, these are the things that form the big boulders, and they all have these distinct star-shaped polyps. They tend to be the longer-lived species. Some of these can be 2-3 meters in height. And the reason why we call these intermediate susceptible species is they tend to get affected by this disease several months down the road to years later. And when we see lesions in these corals, they can get many different, the disease can pop up in many different locations on the colony, but it tends to spread across the coral and kill it in a much slower fashion. The unfortunate thing is these are the corals that can show signs of disease for 2-3 years, and they can, slowly wither away over time. So I just wanted to put this in. This is a picture that, Karen, I'm not sure where you took this, but this just gives you a sense of how high the prevalence of this disease can be on an individual reef. So you can see here this coral, this one, 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 so on, has disease. Basically every picture in the coral that you see, every coral in the picture has this disease. And so you can see that it's quite traumatic. Once it moves into an area, it spreads quickly to all the neighboring corals. And so what I wanted to show you is FWC, beginning in December of 2017, set up what they call these Sentinel Sites. They picked sites on the inner reef, mid-shelf, and outer reef area that they tracked very carefully. They would go out weekly and look at this to look at how many corals are being affected, really to get a better understanding of how this disease is spreading. Is it hitting all the corals on a reef? Does it matter whether the corals are close together or far apart? Really to get a better understanding of what we can expect to occur in other locations. And so you have a lot of little pretty colored dots here that each different color represents a different species of coral. This is in January, and I'm going to show you a sequence going up to June. This is just monthly, but at the time when they first set up these locations, none of the corals were affected by disease. So here's that area a month later, and we're just starting to see one of these early susceptible species showing signs of disease. Then by 2 months later, one of the species that gets hit first, this type of brain coral called Meandrina, started to show signs of disease. And as we continue on into April, we can see many more white dots starting to show up. There's the first few corals that have died from this disease. Again, in here is what percentage of each of those different taxa of corals were being affected. Here is May. You can see a lot of white dots now and a growing number of these black dots. And here is June. So by June, the susceptible species, many of them have become affected by the disease. Some of them are starting to increase 20, 30%, but a lot in these little plots were affected. Okay, so it's really unfortunate that these are all cut off, but I want to now, so we know that when this disease gets into an area, it affects a lot of corals in that area. It will continue to spread for an extended duration. We also know that in some cases the corals will die quickly. They can die within a few weeks to a few months, and this is the same coral. This again was photographed by FWC. This is one of the brain corals. And here, each of these pictures is taken 2 weeks, I think this is January 12th. This is, I think it's a week or 2 weeks apart, but here, this is the area that's affected by disease. Here is the same coral a little later. It started to spread up over the coral. And within a month, about 3/4 of that colony died from this particular disease. So FWC has gone through the hundreds of corals that they identified with disease over this an 8-month period within their permanent sites, and they've looked at how fast it's actually killing the corals once they get affected by it. And what's really interesting, I only put in one of these figures. I didn't want to put in a lot of graphs, but what this is a box plot, and what it shows is this is the mean. This bar right here represents the mean amount of tissue loss per day, and these early susceptible species are losing about 25 square centimeters, or sort of an area about the size of a grapefruit, per day. And so if you think of some of these corals, a brain coral that's the size of a basketball is 20 or 25 years old. And so that coral, when it gets this disease, can die in a period of a week or 2 weeks. So that's 25 years of growth disappearing relatively quickly. There's a lot of variability among this, and what we know from following these corals over time, a lot of times the disease first affects the coral and they lose tissue very, very quickly, but over time it slows down. And one of the important things about that is that this doesn't necessarily mean they're all going to die. I assume everyone knows that a coral is an animal, but these reef-building corals are not an individual animal. They're what are known as a colony. There's many, many polyps that make up this particular coral. And so you can have a disease move across a coral and kill 70, 80% of that coral, but that 20% that's left can survive, it can continue to grow. And so this just shows you within those permanent sites that were monitored over an 8-month period, the percent of the colonies that became affected. So you can see these are the susceptible species here. Very, very high percent became affected, but over an 8-month period, what I want you to notice is that only in most cases about a third, a few of the corals, we had higher mortality, but a few of those completely died from this disease. And in these permanent sites, what we've seen happen over this period is the appearance of new disease corals has declined, and also the spreading rate, the rate of tissue loss has declined over time. So I think that's a very, very positive sign. It's something that we weren't seeing in the early stages of this disease. All the information we had from Southeast Florida when it first moved into an area was that the corals would get hit, 60 to 100% of the colonies in an area, and they'd all die. Well, we're seeing now that there are survivors here, and that's really, really important for the long-term persistence of the reefs and recovery from this particular event. So one of the other things that the in-water monitoring and survey work has done has revealed that there are a number of species that are not being affected by this disease. In particular, 2 endangered species of corals, elkhorn coral and staghorn coral, are not known to be affected. But then also, when you go to some of the reefs that have been hit and that are now what we call the endemic zone, you can still find some of those corals that are the susceptible species on those reefs. And so what we believe it's really important, so this is these are all pictures that I took within the last month on various reefs around here. The starlet coral, this is one of these mountainous star corals. Here's an elliptical star coral. All these things survive. And so those are really, really important for the future of these reefs, because those are what we call certain genetic individuals that are resistant to this disease, and they're the ones that are going to really contribute to the longer term recovery. And the other really important thing, we're more interested in identifying locations that may, for some reason, have resisted the disease. And we've identified certain locations that we call hope spots. These are places that have a lot of these susceptible species, but we haven't seen any disease. So you can still go out onto the reefs, even though what I said is we're losing corals. It's a very, very severe outbreak, but we can find these reefs. This particular location is called White Bank, where there's a huge stand of this mountainous star coral that the corals are unblemished. They're beautiful. So there still are many, many locations that have not been affected by the disease in the endemic zone, places where it's already moved through. So the second piece of the research really is to try to get a better handle on what's causing these diseases. And there's a number of different partners, both FWC, there's some folks at George Mason University, the Smithsonian, USGS, that are looking in detail on these. It's really, really hard to identify what causes a coral disease. The first thing that we can do is you can take that coral tissue, you can preserve it, you cut it into little sections and stain it, and you look under a microscope. And so this is one particular coral, something known as the large cup star coral. It's a section through one of those polyps. And in some cases, what we found is that there are bacteria within these tissues. We don't know if those bacteria are the particular cause. What you have to do in order to identify whether a certain bacteria or some other microorganism is the cause is you have to be able to isolate that particular bacteria. You have to determine what it is and whether it's pathogenic to begin with, because just like if you took a skin scraping and you cultured that, you'd find that there's thousands of species of bacteria that live in there. A lot of those are beneficial bacteria. One of the things that's really important for a coral are these beneficial bacteria that are associated with the tissue, and also the coral, part of its immune system is this production of mucus. It puts this mucus over the surface of its tissue that serves both a protective function from preventing foreign agents from entering, but it also provides a substrate where all these microorganisms live. And a lot of those are good, and they're what keep that coral healthy. They'll produce certain antimicrobial properties to fight off some of these pathogenic bacteria. So basically what you have to do is you have to isolate those bacteria. So you can collect the mucus, you can collect the tissue. We also take sediment samples and water quality samples, and then you have to try to grow those up. The challenge is about 98% of all bacteria that occur in the marine environment are non-culturable bacteria. So how do you get to that point? It's really challenging. So you can identify what they are, you can screen their DNA and come up with these libraries. But ultimately, once you find a pathogenic bacteria, you have to figure out how you can determine what that is. And there's one really interesting, I wasn't going to mention this, but I'm going to anyways. There's a really interesting study with some of the coral disease colonies that we just sampled about a month ago that USGS is looking at, where they're taking these diseased corals and putting amoeba in the tanks with these corals. And these amoeba are going across and eating the microorganisms that are on the surface of the corals. And so they're using those to extract those bacteria and then figure out what they are, and if they're pathogenic, it's one way to move forward and identify a cause. But basically, to make a long story short, once you culture these, if you identify something that's pathogenic, you have to do something called demonstrating Koch's postulate. And what that means is you have to isolate the bacteria, you have to grow it in culture, you then have to take a healthy coral of the same susceptible species in a tank in this case, add the bacteria to it, and if it shows signs of the disease, you then have to re-isolate that bacteria, and if you get the same microorganism there, you can then say you've identified the cause. So it's not easy, but we're making steps towards that. So I'm going to now focus really on in-water activities, and one of the other groups is looking specifically at what can we do to both save some of these precious corals from dying, to treat these diseased corals. Can we go into a reef system and treat enough corals so that we change the trajectory so that this doesn't spread among the other neighboring corals? And can we actually reduce the spread of this disease from one reef to another location? So there's at this point, there's really two different approaches that we've been testing. Some of this started initially in an aquarium system. It's been applied on a very small scale on the reef, and we're trying to scale this up. We can apply some material directly over the diseased tissue. So in the case, here is the disease, and you could put a band of either clay or epoxy that contains either an antiseptic or an antibiotic over that to try to kill the disease. The other thing you can do is something that we call trenching. It's like creating a fire break. Basically, if you have the disease here and you create this break, the way these diseases move is they tend to start in some specific location and they'll radiate out across the coral, killing the coral. And so by creating this little break, you've separated the live tissue on the two sides, and so if the disease moves towards the break, it may not be able to pass that into another area. So the first treatment, something that was done quite extensively, really off the, from between Broward County and Miami, is the use of chlorine. This chlorine is a powder, and it was mixed into epoxy, and that chlorine was then applied both at the band between dead, exposed skeleton, and living tissue, right in the diseased front. So it was applied right around here. And then it was also, here is the epoxy right here. There was also a fire break created. And so in certain species of coral, this has been very, very effective. Applying the band itself didn't always necessarily work, because you can see here, this little white area is a piece of the diseased tissue that managed to spread underneath this epoxy and start affecting corals. But then by having this fire break, it moved up to that fire break and then couldn't spread anymore, and that particular lesion was effectively treated. We've not had as good success using this antiseptic in the Florida Keys, but we have had much more luck using antibiotics. Now, antibiotics always brings up a lot of fear, because you can't just go dump lots of antibiotics in the ocean. There's many reasons. One of the main reasons is you'll create these antibiotic-resistant bacteria, and so down the road, if we had another disease outbreak, we then necessarily wouldn't be able to treat them. In a tank situation, it's really easy, and so the first experiments were trying different types of broad-spectrum antibiotics, and it was really targeted at saving one particular type of coral, that's pillar coral, because that coral has been knocked back throughout the Florida reef system, and we've lost a lot of the different genetic diversity there, and so we want to save those. So some of those have been brought into aquarium facilities, but then some of the diseased pieces of tissue were very successfully treated. So here's a colony. The white is all area that's been denuded. The disease front is here. So it was basically bathed in these antibiotics, and it very, very successfully eliminated the disease, and these living tissue has continued to grow on these particular corals. So mainly Karen Neely's lab and Cindy Lewis from KML started working on, first in an aquarium situation, trying the use of antibiotics in different mechanisms and coming up with a way that you could do this in a field where you're not putting a lot of antibiotics in the water. And so they did a lot of different trials with a number of the different susceptible species, using both applying antibiotics right to the disease lesion and also trenching. And one of the key things here is, as I mentioned, you can't just dump antibiotics into the water. You have to put a very low concentration. You want it to be applied directly to the place that is being affected by this disease so that you'll have the best response. But you need some sort of mechanism to do that. And so there's been a number of different compounds that have been used where the antibiotic is mixed with it. This yellow that you see here is shea butter. And then also there's a company called CoreRx that has made a silicon-based material that you can mix the antibiotics with this material. And then you apply it to the coral, and you basically press it into around the lesion. And that has shown in the small-scale field trials really, really high success. So here are 6 of the different susceptible taxa that have all been treated with the use of antibiotics, either in shea butter or this silicon-based material. Some of these, the scale is pretty small. And so where we are moving with this is we want to scale up these interventions, and we're doing this in several different approaches. This involves, again, a large partnership because this is a really labor-intensive effort. When you get to a reef, there's a lot of diseased corals. You have to select which corals you're going to treat and why. And so there's 3 different approaches we're taking. FWC has established within what are called these SWIG sites, where there's monitoring going on every few days, these plots where they're looking at this every day, and the minute the disease first appears in this area, they're going to go in and start treating these corals and continue looking at those over time to see within those little plots if it's possible to change the trajectory, to save some of those corals and prevent it from spreading throughout those little plots. We want to move from that with a partnership that DEP has established with Force Blue. They are supporting a larger scale intervention efforts. They're going to be starting work here around November, and so one of the approaches is to pick selected patch reefs, the entire reef, again, to follow these over time, and the minute the disease starts to appear, put all your energy into trying to treat that patch reef to see if it's possible to eliminate the disease from that particular area and reduce the spread. And then the other component of this is we know that there's certain corals that we call high-value corals. In southeast Florida, there's these things called big mamas, the big, huge star coral colonies, the things that people that go out diving know really well. They're the things that are, as I mentioned, the most important frame builders. And those bigger corals are more important than a small coral from the potential for recovery of these reefs, because the bigger a coral is, the more offspring it produces. It produces more sperm and eggs every year when it spawns, and so by saving those, you're having a greater overall effect on the reef. And so we've been identifying locations where those particular high-value corals are, and some of those, we'll track those. When they show signs of disease, we'll follow them over time, treat them, and try to eliminate the disease. So the third group is doing what's called coral rescue. What we're looking at is we want to make sure that we preserve both the genetic diversity and the species diversity that you find on reefs throughout the Florida reef tract. And we want to take some of this material and bring it into these both land-based facilities and in-situ nurseries to establish what we call gene banks. This is basically what they've done with a lot of other endangered species around the world, mammals, other sorts of organisms, so that we can protect that so that we have it for the future. And the idea is that we start having them reproduce in captivity or in our in-situ nursery. We propagate those things, and ultimately we put them back onto the reef. And so we started to see how labor-intensive this is and whether it's feasible at all. We went throughout areas that have not yet been affected by the disease. So this is what I was telling you before was the pre-invasion zone. Identified certain locations that are outside of our sanctuary preservation areas where we have these vulnerable species, and we're collecting a certain proportion of those in order to bring them into these facilities. And so a very successful pilot effort just involving 200 corals of 12 different species taken from 3 sites. These are the 3 sites where they were collected. They were transferred temporarily to Keys Marine Lab, and the idea is that we are going to scale this up, and we've established partnerships with a number of different universities. We're working with the American Zoological Association for some of the public aquaria to bring these corals into those facilities. There'll be some of those that go on public display, so to improve the understanding. So when someone comes to this aquarium, they can understand that these are corals that came off the Florida reef tract that were saved from this disease, why we're doing this, but then also facilities that are capable of both maintaining these and starting to work towards propagating these corals. So the next group that I want to very briefly mention is, what do you do to start restoring the reefs? This is a really, really big question because we need to know when we can start doing this, we need to know where we can do this, and most importantly, when we do any sort of restoration efforts, we need to make sure that we minimize the risks. We don't want to cause the disease to become more severe. We don't want to lose those corals we're outplanting, and so we have to really, really take this step very, very carefully. All of you probably know very well about all of the restoration work that's been done with Staghorn coral initially, there's some 20,000 of these that are being planted onto the reefs by the 3 large groups every year. Well, more recently they've been moving into some of these other species. There's people now that are starting to propagate some of these boulder corals, the ones that are susceptible to the coral. This is a photo that I took at Coral Restoration Foundation's nursery. A lot of this is one species of boulder coral that Ken Niedermeyer really has propagated quite extensively in this nursery. There are really 4 key partners that are doing a lot of this restoration work now, but the idea is that we want to plant these back out, but we have to make sure that we do it very, very carefully. So we have to look at these different zones where we're going to plant it, and there's new techniques that you can use for these slow-growing corals to really turn them into boulders very, very quickly, but as I mentioned, we have to make sure that we don't increase the pathogen load, we don't want to restart the outbreak in places or enhance the spread of these diseases, so we're looking very, very carefully. The other one concern with restoration is some of the species that are not known to get the disease, we have to make sure that they're not carriers for this disease, and so we are doing some small-scale studies looking at outplanting of staghorn coral and elkhorn coral to make sure that they, first of all, don't get the disease by planting them around a diseased coral, and also to make sure that if we take these corals from an area that is experiencing an outbreak of this disease and plant them somewhere else, that they don't spread the coral to these non-susceptible species. And so the last group that I just want to mention is a lot of the effort involves getting people involved. We want people to help us improve our understanding. We also want to communicate this and share this information with both different user groups within the Florida Keys as well as worldwide. And what we've recently learned is that we think that this same disease may now be appearing in other locations in the Caribbean. And so we're trying to share a lot of that information. One of the things that we're trying to do is ensure that we don't contribute to the spread, and so we've come up with a protocol to decontaminate your dive gears so that if you are diving in a diseased area, you don't get the pathogen onto your dive gear, and then if you dive in a healthy area, that you don't spread the disease to that location. And then the big component of our citizen engagement group is really teaching people about the corals, how to identify the different diseases so that they can be the eyes in the water. We can't go everywhere. The reef track is huge, but we need more people out there looking for this disease, understanding what it's doing. So Sea Grant really has been, Florida Sea Grant has been leading the effort to develop some of these training modules. They've done initial pilot training at the Florida Keys Community College, and there's several other ones that are coming up where they're starting to teach people about how you get in the water and start doing the monitoring to understand really what's going on. And then this is just my last slide. We also, there is now information on the Florida Keys National Marine Sanctuary website about the disease, which is regularly updated. At this point in time, all the disease observations that the public makes is we're asking them to report this to CFAN so that we can understand really what's going on in these places. And one of the real key things is we want everybody to get involved because we need even more partners and more people involved to understand and address this coral disease. And with that, I would be happy to take questions.
Thank you. Andy, let's wait for a microphone.
And I believe it's in December, there's supposed to be a significantly large gathering of reef experts at Ocean Reef. And I was wondering, is this likely to be a focal topic?
Yeah, so it's probably one of the largest gatherings for coral reef researchers that's probably ever happened in the Florida Keys. There's over 500 participants there. There's a whole section that's devoted specifically to coral disease that will be looking at what considerations you really need to make to ensure that as you're moving forward with restoration that you do this in a way that is very risk averse.
Two questions. One is, once the disease has decimated an area, has it vacated the area?
So we call the areas where the main outbreak has moved through the endemic zone, but what we've seen is new occurrences of disease will still pop up in those areas. It's a much lower prevalence than you saw before. And I don't like the word decimated because it really isn't decimating the reef system. It's killing a lot of corals in some cases or causing partial mortality, but I really don't think we can say anywhere that the Florida Keys has been decimated by this disease. There still are corals left there, there's still a lot to see, and there's little corals, there's pieces that survive that are still continuing to grow.
And after the disease has gone through an area, is there any immunity to the ones that have survived?
So we're starting to look at that, and the way that you do that is we've done a lot of that work with elkhorn coral and staghorn coral to see if corals are resistant to certain things. So it's not just the disease that you want it to be immune to. So we know that there's, just like people, there's all these genetic individuals, and some of them have a higher tolerance or resistance to disease. Some of them are more tolerant of high temperature. Some of them are more tolerant of sediment stress. And so we're looking for some of those to find out what they are. And we think that the corals that have not been affected in areas where the disease has moved through are some of the corals that we really want to start to propagate, because those are likely to be the candidates for the ones that are resistant to the disease.
So there's resistance and then immunity. So do they get immunity? Do they build up anything within a coral that was susceptible that now is able to, if it survived the onslaught, then isn't susceptible in the future?
We hope not when we identify those resistant species. We don't know. So corals have what we call an innate immune system. It's really different than a human immune system. I mean, it's very simple. They have certain cells. They have receptor cells. They have immune-related genes so that they can produce antimicrobial compounds, for instance. And so some people are starting to look at some of those things, and they know that in the case of temperature stress anyways, there's certain corals that build up more of these immune-related genes and are able to produce more of these compounds that help them tolerate it. So we don't know yet, but we hope that that's the case.
Any other questions? Well, Andy, welcome aboard. I think this is our first presentation since you joined us here. Fantastic to have you on the team. Very, very pleased. Thank you very much. It's a great presentation.
Thank you.
All right. I'm sure many of you are closely watching the ongoing harmful algae bloom that is affecting parts of the west coast of Florida. We are fortunate to have Kate Hubbard from FWC to provide the latest on this event and implications and potential impacts for the Florida Keys. Kate will also be joining by teleconference.
There are 3
Okay,
parties
we're
in
good.
conference.
Just a second.
Hi, Kate, are you with us there?
Hi, everyone. Yeah, sorry about that.
No, quite all right. I think we need another minute to get your slides up on the screen.
Okay.
Yes. I'm sorry, everybody. I kind of neglected something. Superintendent Penguin has an announcement for us. Thank you. Sorry about that.
No worries. No worries. I just wanted to take a moment to introduce someone who's new to our team. We have a new deputy superintendent who's acting. He is Michael Carver, standing behind me. Michael comes to us from Cordell Bank National Reef Sanctuary on the West Coast, where he is also he's not an acting deputy superintendent, he is the deputy superintendent. Lisa is moving into a new role. She is now our regional response coordinator. So recognizing her deep skill set, the sanctuary system wants to use her beyond the Florida Keys. So she is going to be continuing to be here, work with us, but also be supporting the other sanctuaries in the region. Michael is with us. He had a lot of sense of adventure because he had never actually been to the Keys when he agreed to come here. So we're very, very glad to have him. He has a lot of budget, operations, facility experience, which is something we really need his help with. So if you get a chance during the break, please introduce yourself. And thank you, Michael.
Is it a is it permanent?
No, not yet.
Temporary.
So we'll be advertising for a new deputy superintendent. The paperwork is in the process.
Right.
Federal wheels turn slowly in the hiring process, but we're working on that. And in the meantime, he's here to help us out.
Are you considering it as a full-time position? He's dressed appropriately.
We like it.
All right, Kate, just another minute here. We're getting your slides up.
Well,
Okay. You just see black?
Beth, I can see your mouse move when you moved around up there.
you can?
Yeah.
Okay, but I can't.
Can you see anything now?
No.
See your mouse?
Yeah.
Well, it's the wrong presentation.
You can see it?
There.
There we go, Kate. I think we're looking good now.
She's got to go into presentation.
So if you go into presentation mode, Kate, we should be okay.
Can you guys see that?
Yes. There you go.
Yes, perfect.
Okay. And let me know if I need to speak up at all. So I'm going to talk to you about some harmful algal blooms and the implications for the Florida Keys. And I'm presenting the work not just of myself, but of the huge team. And I just wanted to start out and introduce marine phytoplankton, or algae. These do form the base of the marine food webs, and they also produce the air that we breathe. And these include both cyanobacteria and single-cell eukaryotes, and those are shown in some of the images here. And all algae require light nutrients, and they also have species-specific environmental conditions. And Florida has over 50 different harmful algal bloom species, and I'll explain a little bit more about that in a minute. Our monitoring greatly informs our research here at the Fish and Wildlife Research Institute in KC. And our work very closely mirrors the Florida Department of Agriculture and Consumer Services, or SAC. They're the management authority, and they monitor our shellfish harvest area zones. And so we provide technical support through both our monitoring program, and that's largely microscopy based, as well as our biotoxin testing. And we're heavily involved in method validation and in some cases development, so that we have a very active role in research that again informs our monitoring. And we couldn't do this without numerous partners, and some of our primary partners are shown here around the edges. But we also work with numerous county agencies, citizens, volunteers, and many other partners. So I wanted to just give a quick overview of what I would talk about today. Just in the past few weeks, the scope of my plans sort of changed based on the bloom that we've been having of red tide. But I will first start out and talk a little bit about marine cyanobacteria blooms in Florida Bay. We've heard a little bit about those earlier, and there have been some great introductions, so that would be wonderful in terms of giving you some context. Sorry about that. In terms of red tide or Carina brevis, I'll talk about some historical observations statewide as well as in Monroe County, and provide somewhat of an overview of the 2017-2018 bloom. And then throughout that and a little bit at the end, I will talk about some ongoing research. So I just wanted to start out with a quick overview connecting land to sea. We have regional inflow and outflow from our nearshore inland areas out to our estuaries, and we also have interaction where we have ocean water that can make it into our estuaries. And so flow patterns are complex, and they don't just vary across these different systems, but they also vary from year to year. And this depends on precipitation as well as water management strategies, as well as events like we've heard today in terms of things like hurricanes. In terms of some of the potential bloom impacts, freshwater taxa and nutrients can be transported into Florida's estuaries and lagoons. And these can lead to cyanobacteria blooms being transported from the lake into these systems, and sometimes these blooms can be dominated by freshwater toxic species. And these blooms have occurred recently in the St. Lucie River and Coosawhatchee and associated estuaries. Red tide is not caused by these blooms in any way. However, it can use coastal nutrients as present, and I'll talk a little bit more about what how red tide initiates when I go over this present bloom. Just
during reduced freshwater flow, we see high salinities, and sometimes these are associated with marine cyanobacteria blooms, and these are very different from the freshwater blooms that can sometimes occur. These can be dominated by an organism called Seneca, and these are bacteria that are, again, able to photosynthesize, so they're able to produce oxygen. In terms of a very, very quick overview of Florida Bay and marine cyanobacteria blooms, in the late 1980s, there was an extensive seagrass mortality event, and in the early 90s, cyanobacteria blooms dominated by this tiny bacteria, Seneca, were associated with sponge mortality, generally in central Florida Bay. And this was just showing some of that data from a paper by Ecologic at the University of Florida. And this is showing chlorophyll concentrations that you can see that they're quite high throughout much of these years. And then in the 2000s, 2005 to 2008, in particular in Barnes and Blackwater Sound, again we have Seneca blooms, and these were associated with different mortality events. And you can see in these plots that I show here, this is chlorophyll data again, and you can see this huge spike that occurred in March. And just to give you a sense of the timeline for some of the events in Blackwater and Barnes Sound, there were numerous hurricanes that passed through in 2005. There was a sponge mortality event going on through much of this time. And there was also a Seneca bloom that continued in the area until 2008. And then a seagrass mortality event. And then in terms of Central Florida Bay, there's a Seneca bloom in 2013, and this was associated with sponge mortality. So I wanted to give a little bit more context about the 2013 bloom in particular and some new technology that we're now using to try to track these blooms over time and to get a better sense. Hopefully from the prior overview that I showed you, you can get a sense for the fact that these blooms can occur in coincidence with other ecosystem disruptions. However, the timing of those disruptions and the succession tends to vary from event to event and perhaps from location to location. So with the cyanobacteria blooms in Florida Bay, back to the present slide, I'm showing some images. Let's look on the right first, and you can see those are the same legs on the top. Those legs are showing conditions where we have typical clear water in Florida Bay, and so you can get a sense for the discoloration when we have a bloom in the image shown below that. Again, same legs, same boat, different conditions. And then if we go back to the left, you can see some images of cells. These were taken in 2013 during the Florida Bay bloom, and they're very small, around 2 microns, and so they're difficult to quantify. However, we can use a method called flow cytometry, which allows us to quickly quantify these particular cells, and I'll discuss that in just a minute. They can reach over 10 million cells per milliliter, and they can, as I mentioned before, be associated with both sponge and seagrass mortality. I just wanted to give a quick overview of flow cytometry. In general, I'm going to highlight just a few things. This is a tool that we use for a few different types of algae that are especially small and difficult to identify. So imagine, I just showed you some coccoid cells in the prior slide, but imagine a lot of things that are similar that basically look like small, just balls. Those are very difficult to identify. However, we can use an instrument called a flow cytometer, and basically what that allows us to do is to put a sample, a seawater sample in, and we can use either a live sample or a steamed sample, depending on what we're interested in. And basically, each single cell is imaged using a laser, and the laser collects information about the cell, and it measures 14 different parameters. And for our interest, we're really interested in the size of the particles, as well as their chlorophyll pigmentation, because cyanobacteria have pigmentation that allows us to differentiate them from other algae. So that's basically what I need to show you with that. And this is just showing a plot where on the bottom, this is an image where we have orange fluorescent So this is the type of fluorescence that is specific to cyanobacteria, as well as red fluorescence, which is more general. And you can see in this plot that we have cyanobacteria that we're able to pull out of a mixed population based on those characteristics. And we can do that by running cultures as well as field samples during blooms. And then this is showing some of the data. So let me orient you during the 2013-2014 bloom. If we look at the bottom, that's showing some of the flow cytometry data at different sites in Mystery Basin. That was one of the areas where sponges were most impacted. And this event, we really relied very heavily and partnered with the Marathon team, the Marathon FWI team. And they were very interested in what was going on with the sponges and pulled us in. Some of our sampling sites, you can see we sampled during the bloom event in October, and then as the bloom was subsiding again in November. And during November we actually sampled during another peak phase. So what you're seeing here are two different satellite images, and these are showing the relative chlorophyll abundance, and we can use that as a proxy for tracking these blooms. But it's still really important to be able to verify that they are indeed cyanobacteria and not some other type of alga. And so that's where the flow cytometer comes in, especially for identifying these small species. Sean Hu at the University of South Florida is also developing specialized algorithms to better pick out these picocyanobacteria blooms. Again, to pick those out from the overall chlorophyll signal so that we can better track them in space and time. And someone in my lab group, Jen Canavaro, is working on a paper describing several time series analyses of those data that have been used for developing those algorithms. We've also used flow cytometry for monitoring event response in 2016 and 2017, and we're able to capture the onset of the bloom event then. So just to give a bit of a conclusion for the cyanobacteria, we do see picocyanobacteria blooms, and they continue to episodically disrupt Florida Bay. They're sometimes associated with these negative ecosystem effects, including sponge mortality and seagrass mortality. We can use flow cytometry in concert with our satellite observations to monitor these blooms in Florida Bay. And we do have a new project looking at sponge feeding, both the rates and the selection, again using flow cytometry in cultivated versus wild sponges at different ages. And this is part of a project that is being led by FWI and Marathon Group, and it's funded by the Department of Environmental Protection. So, oops, my slides have a mind of their own. Let me go backwards. So now we're switching gears a little bit. I don't know why it's doing that. I'm not pushing any buttons. I'm trying to go backwards. Be patient with me. Thank you for being patient in general with the technical issues. And I'll take this time to say I'm sorry I can't be there in person. And I'll jump right back into what is red tide. So what is red tide? And I mentioned harmful algal blooms. These are blooms that form when algae proliferate and grow, divide, and then they produce toxins. And in particular, we focus on algae that produce biotoxins that can accumulate in shellfish, but there are also other HABs that we keep an eye on, and we call them HABs. And harmful algae can also cause low dissolved oxygen. And so Crimea brevis is obviously one of the big organisms that we focus on here in our red tide group, and it produces a toxin called brevetoxin. There are over 20 different forms of brevetoxin that can be produced by Crimea brevis or that can occur in the environment. And we know that these toxins can kill fish, birds, turtles, manatees, and dolphins. You can see some of those impacts in the images that I've shown here. We also know that these toxins can be harmful to human health. They can accumulate in bivalves, and they can cause shellfish harvest closures. Crimea brevis, once cells reach 5,000 cells per liter, we typically will, it's important that shellfish beds are closed because that's a mandate, and it's the only only algae that actually has a cell count tied to closures of shellfish harvest rather than measurement of toxins. Sorry, every time I push it, we're advancing a few slides. Okay, so since November 2017, that's when the present bloom initiated, and our group has processed over 10,000 water samples via light microscopy. This has been one of the longest documented red tide blooms since our monitoring got started. Our database goes back to 1953, but we know a little bit about some of the blooms that occurred in the 1940s as well. And so the present bloom has lasted, we're currently in the 12th month, and so it's one of the 5th longest documented blooms that we've had on record, and that's based on observations of over 100,000 cells per liter. Each one of the dots on the map on the right represents one sample, and you can see that these are, this map is showing the prior status report, and you can get to that status report via the website that is put on this. You can see our microscopists hard at work. There's a lot of work that goes into making these samples get onto the map. And what you can see with this most recent report is that we've had blooms in northwest Florida, southwest Florida, a recent identification of Carnea brevis in the Keys, as well as the recent occurrence of Carnea brevis on the east coast of Florida. And just to put that into some context as well, there have only been 8 prior East Coast blooms that we've observed in our historical record. So, okay, I really am sorry because I'm pushing it really late. Now that we've seen the slides a lot of times, you know, you have them memorized at this point, but blooms initiate 10 to 40 miles offshore and they initiate at depth. There is one hypothesized initiation zone that potentially feeds both northwest and southwest Florida blooms. This is south of Big Bend and extends to south of Tampa Bay. And depending on the combination of offshore currents and the schematic, as well as surface winds, we have conditions typically starting in the late summer, early fall, that are conducive for transporting cells onshore at depth via southwestern currents. These cells can then be upwelled into the surface waters, and that's where we typically see blooms manifest in coastal environments. And so we know, I'm trying to press the button really. Okay. Oh, not like that. Carnea brevis is very ecologically flexible. We know from comprehensive lab studies as well as field studies that this alga has a very broad salinity and temperature tolerance, and it's also capable of using a diversity of nutrient sources for growth, many of which are shown here in this simplified schematic. And we know that they can, for example, use atmospheric nitrogen that is brought into the system by offshore algae, another type of cyanobacterium known as trichodesmium, that can take up this nitrogen from the air and convert it to forms that Carnea can use. We've seen a lot of blooms of trichodesmium this past season. There are other factors that can contribute. Sediments can play a role. Upwelling of deep ocean nutrients can play a role. The grazing, waste, degradation, and general recycling of the planktonic community itself can help to sustain blooms. Fish kills can cause blooms, a nitrogen source for blooms, and then of course we also have sources that are put into our systems through estuaries, and these include land-based sources as well as anthropogenic sources. I wanted to just show on the right, we are looking at Carnea brevis in the lab, and we're able to now develop experimental chambers that more closely approximate the actual environment. And so what you can see here are Carnea growing in these culture slabs. And what we have, we're using LEDs to simulate the actual light levels that would occur in the surface ocean during bloom season to get a better sense for how quickly they may be able to divide under those conditions. Okay, so we know that currents can transport red tide south, and so I wanted to really focus on Carnea brevis in Monroe County over time. And if we look at this graph, I'm showing Carnian brevis cells here, and with the scale, these are very high concentrations, just to give you a sense. So in terms of taking out a few of those events, especially the ones since our monitoring has picked up in the 90s, we see that those events coincide with the longest lasting blooms that have previously occurred. They also have occurred in January or February, and so that's something where these events typically occur in the wintertime. And then this is now showing that same data, but I am cutting it off so that we just have roughly over 1 million cells per liter shown, and you can get a better sense for the variability over time. Now that we're looking at lower cell concentrations, we still see Carnia brevis in the system, typically from December to April, and you can see that it's not always present throughout a long period of time. And we commonly observe it since monitoring has increased. So it's not completely rare to have a tide in Monroe County. And so just to give a sense of the fish kill reports that have occurred, these are extending from November, the beginning of the bloom, through September. And you can see that some of the counties to the north have been quite heavily impacted. And you can also see here that Monroe County has had several events. And in particular, I wanted to just speak about those briefly. They again occurred in January and February. I'm now showing monthly summaries of our cell count data. So each of these different dots represents a different cell abundance. And so the warmer the colors, the higher the count. You can see that in January, we saw some Carnia brevis, low concentrations down near the Keys. And then in February, we saw up to medium concentrations and had reports of offshore fish kills in Florida Bay. And those extended through the 20th of February, and these included different species, and I've listed several of them here, including snapper, mullet, grouper, pufferfish, trout, catfish, cowfish, finfish, hogfish, remora, mackerel, filefish, and others. So these events can have consequences and fish kills related to them, but they also were relatively short-lived. And for this bloom in particular, we saw that the bloom was affected north and south several times, but we didn't have that dissipation to the west that sometimes helps with bloom termination. With this present bloom, we used a combination of aerial surveys as well as some of the satellite imagery that I've shown you already to assess bloom extent. And so with the satellite imagery here, we've got chlorophyll data related to Carnia brevis. You can see we have our cell count data overlaid. This is actually from mid-September. And as you can see where I've highlighted on the bottom here, this is showing you the potential transport of Carnia brevis from around the Marquesas and then south along the reef track up to Jupiter, where we first saw Carnia brevis starting on approximately the 30th of September. As we now look at the images on the left, these are from some of the aerial surveys that we've conducted. These were from the aerial survey on September 6th in Southwest Florida, showing this area in the box here. And you can get a sense for how patchy our tides can be. We're not seeing these same concentrations based on reports coming in from visual observations, people out on the water, and as well as some of the aerial surveys that have been conducted in response on the East Coast. I wanted to mention a new product that we have that has been of value. This is our new interactive daily sample map. It contains the last 8 days of sampling and it's updated each day. You can get to it most easily by going to our status page. It's right at the top there, but I've provided a direct link here. One of the reasons this is so important, because we're in event response mode, we do have samples going into the database at different times. And so you can get a sense for what's going on in a particular area. And just recently we did start to see, as I showed before, red tide in the Keys. We're still tracking that to see if they're going to be related impacts. In case you weren't aware, our data gets shared with NOAA each day, and it's used to help generate respiratory irrigation forecasts along with models of ocean winds and currents. I provided the website there as well as the current forecast for both the southwest coast as well as the east coast. And so you can see that because of those hill counts, they're now predicting that there will be very low respiratory irrigation in parts of the Keys.
Can you say that one more time, please?
Pardon?
Say that one more time. Repeat that, please.
The very low respiratory irrigation level, shown here in the dark blue color on the Southwest report. And so in terms of interpreting this, those very low colors, we can go across in the graph here and get a better sense for who the expected population might be. And in that case, it would be somebody who has a chronic respiratory condition. And I forgot to mention that these toxins can be, the brevet toxins that Corynea brevis produces can be aerosolized, and they can, that typically can happen when sea spray happens when waves are crashing. Depending on which way the winds are blowing, those aerosolized toxins can either be brought closer to shore or offshore. These forecasts help us predict when conditions are likely to be favorable for going to the beach, for example. And these are just snapshots, but there are more detailed forecasts available on NOAA's website. So this is another image from the USF Optical Oceanography Lab, from my news lab. And this is giving a sense of current conditions. This was taken on Saturday. There's a few things to point out here. One is that we are continuing to see high chlorophyll in southwest Florida, both offshore of Pinellas, Manatee, northern Sarasota counties, as well as generally offshore of Charlotte and Lee counties. You can see that we have some elevated chlorophyll offshore of Monroe County as well, and we are continuing to see that string, if you will, of chlorophyll extend further north. And these are some of the areas that are being impacted by the East Coast Corynea brevis bloom. In terms of our event response, I'm not sure how many of you are aware, but right now there is a very comprehensive NOAA cruise. This was a routine survey, and it's been extended now to go up to Pinellas County. And while even I was on presenting, I got a call from Chris Kelble, who's leading that effort, to see if they should perhaps even go further north. On the East Coast, we're working with them to get increased sampling at the county level. And we have a partnership with Moat and others in the Florida Keys to get more samples from that area as well. In terms of the Northwest, we're working with volunteers that can sample up there, but we are expecting a reduced number of samples until we can get a better handle on the more pressing emergency of what's going on with the passage of Hurricane Michael, and whether or not this signal that we see up in the Panhandle is related to Corynea brevis or perhaps something else. We will do our best to verify that in the next few weeks. I also wanted to mention another product that we use all the time, and this allows us to predict red tides and their impacts. And this product is available to 4 different locations around the state. This is the product that is specific to the Florida Keys area. And so you can see with these data, I've shown the surface predictions on the left and your bottom predictions on the right. And what these suggest, based on winds and currents, is that over the next 3.5 days, if we, for example, follow these right here, These X's indicate where the sample was collected. The color indicates the relative concentration of Crania brevis. And then we can follow that to get a better sense for where those cells are likely to be in 3.5 days. And so it looks like the surface populations are likely to be affected to the west. When we now look at the bottom populations, we see that those are likely to be affected along the shelf. And so that's something that, again, we'll continue to try to keep an eye on. And it really points to the need for long-term and sustained observations, not just at the surface, but at the bottom. With some of this effort, I know that for the NOAA forecasts that I mentioned, those are 4 days. These are 3.5 days. These are much like weather forecasts, so we can't go beyond that without decreasing accuracy. But we are interested in trying to do that and potentially go out to a week. We're also working on a project right now where we're looking at seasonal forecasting and trying to get a better sense on how to forecast bloom severity. I wanted to wrap up and just speak briefly about a research project, the Marine Biodiversity and Observation Network, or MBON, that is helping to map marine biodiversity in national marine sanctuaries. And as part of this project, environmental DNA, or eDNA, is being used to help target different organisms, spanning microbes to mammals. And we're doing that using a single seawater sample, so we are able to concentrate a liter. And if you can imagine a fish swimming against a piece of coral or a piece of mucus that accumulates cells from the environment that's in the water, that gives a signal that is a DNA signal that we can track. And so we can use that, again, to look at organisms across all of these different levels. This method is great for looking at phytoplankton because they're single cells, so they're caught and it's not necessarily as complicated as some of the vertebrates and higher trophic levels. This is a hugely collaborative project, and the primary collaborators are shown here. This is just a quick overview. I already mentioned this, but we're able to use one extraction and use different primer sets and able to then target these different trophic levels ranging from microbes up to vertebrates. And I don't need to go into the details of that because there's a paper that explains it all, but I'm happy to do that at any point if it's helpful. And I just wanted to mention, again, don't get too overwhelmed with this. It's a heat map showing some of the diversity of the sequence data. Now that I've said what it is, you can kind of ignore it other than to see that the phytoplankton shown in green ends up here, 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 and here. And these are in order of the 50 top taxa. So a lot of the phytoplankton do represent the 50 taxa that were observed the most recently. And using this approach for doing deep sequencing of communities, we were able to identify multiple different harmful algal bloom species. And some of these are beyond the ones that we typically monitor, like Crania brevis. And so I just wanted to mention some of those here. However, they tended not to be the most dominant for the most part. And this is coming out in an accepted manuscript. And there's a NOAA cruise, they have this out right now, and they're doing this type of sampling so that we can have a better sense of what goes on during a big red tide event like this, where we know that there is a lot of potential for there to be wildlife mortality, as well as different things going on at the microbial level. Okay, and so with that, in terms of the red tide event, that's something where we are very much continuing to monitor that and keeping an eye on it. It does need to be creeping up the East Coast, and it takes a huge network to monitor, track, research, and predict Florida's big red tides. I only touched upon a few of those today, but I could tell you about lots of others, and I think I probably already used my time. But I just wanted to say that our website has a ton of different information and links to the different tools that I showed today. So with that, I will call. Thank you.
Thank you, Kate. Before we open it up for questions, I did want to mention that we have Chris Casper here from the National Weather Service, and I wanted to give him the opportunity to show any products that he may have with the harmful algae blooms.
Yeah,
Sure, I'm sorry.
That's it. All right, thank you. I'll be brief. I'm with the National Weather Service office down in Key West here. We serve all the Florida Keys locally here at adjacent coastal waters. And as Kate mentioned, you can see that the science and the service behind harmful algal blooms is really a multidisciplinary and multi-agency effort, which is kind of interesting. You have biologists, oceanographers, modelers, and meteorologists kind of working together across the agencies to provide this information. You saw the graphic she referenced with the respiratory impact showing very low respiratory impacts in the Keys currently. If we ever get to that red area, high respiratory impact, which occurs about once every 4 years, somewhere in the Keys on average. If we ever get to the high area, then the Weather Service will kind of join the effort with our dissemination muscle, and we'll issue what's called a beach hazard statement, which basically provides a little more detailed information with calls to action for resource managers and the public. And again, that would be only if there was a high respiratory impact. Otherwise, you know, one thing that about the harmful algal bloom forecast issued by NOAA, which is available at tidesandcurrents.noaa.gov, those forecasts incorporate the wind forecast from the Weather Service outlets, not only in Key West, but also on the Florida Peninsula. So those wind forecasts are actually coming from human forecasters that are looking at multi-model ensembles and bias correcting for local knowledge better than any one model provides. So you know, that kind of goes into that effort. And that's basically it.
Great, thank you very much. And with that, we'll open it up to the Advisory Council for questions for Kate. And Kate, thank you very much for taking your time out today to share this information with us. Are there any questions for Kate?
And make sure you guys speak really close to the phone so I can hear. Thank you.
Hi, Kate. Is that good? I apologize if I possibly missed this in your presentation. Do you use any data collected from NOAA's phytoplankton monitoring network, that citizen science data?
So we were aware of the phytoplankton monitoring network, and we primarily, because of especially the regulatory closures associated with current aggressive constitutions, that's one of the reasons why we have such an extensive statewide monitoring network, but also due to some of the issues with identifying some of the key hazards. And so we do have our own citizen volunteer network, and we rely on them to help collect samples throughout the state. But we still have those samples sent to our lab in St. Pete, where we have basically a very well-oiled machine for accepting those samples, getting them in the database, and so on, so that we can generate reports quickly. But no, we are very much aware of NOAA's phytoplankton monitoring network, and in terms of trying to pull together, I know that they do more work on the East Coast in particular, so that's a good point.
Thank you. I have one more question, actually, for maybe you and Chip. Chip, you mentioned that one in every 4 years having a high level of Cornea brevis on average. Is that in one part of the Keys versus another more often?
Anyone, it could, 99% of the Keys could be unaffected if there's one case of high respiratory impact, and that would count.
Thank you.
Andy?
Thank you, Clint. Hi, Kate. Thanks very much for your presentation. I do the public relations for the Keys Tourism Council, so you'll understand the nature of my question here. I have many. I don't want to ask them all. I'd like to maybe chat with you sometime tomorrow, maybe, if that's possible. But that map is an extremely important communications tool for everybody in tourism in the state of Florida. And I just, make sure, that we understand that map is crucial, and accuracy and timeliness is really, really important. So I'm curious, some of the points that I look at, show like reports that are done 7 days ago, 8 days ago. Others are 2 or 3 days ago. And I was just wondering, how does that mechanism work for you guys?
Sure. And so right now we are trying to be extra responsive in some areas that are just now recently being impacted by blooms. And so we may be getting multiple samples within an 8-day window. The new interactive map is updated each day, but includes data from the past 8 days. And so the most recent data is what you see in terms of the dot color, but the little table that pops up when you touch on that sample, that allows you to scroll through and see the concentrations and the samples that were collected prior in that week.
Okay, and
so
then...
it does include 8 days, and so we do have sites, especially on the East Coast now, that have been sampled multiple times.
Okay, and then there's 2 other quick questions, and I'll, and if folks want to go to lunch here. At what point, and we happen to have the county health director in the room here, at what point do they need to be concerned in terms of actually issuing some kind of advisory or hazard warning? That's number 1. And then the second, my last question is, the couple, I guess a week and a half, 2 weeks ago, when we first started noticing, I guess, moderate levels of red tide up in like Palm Beach, Fort Lauderdale, there were some reports of dead fish pushing in. Were those fish that got wrapped up in the loop current from off of like Sarasota, those areas, and came back around, or were those fish kills off the East Coast? Thank you.
Okay, so in terms of the advisory or hazard warning, I'm not sure if you're referring to Monroe County in particular. But yes. I know that each county has been handling that with both the local Department of Health as well as the state Department of Health. And so that's something where each county is handling that a little bit differently. So we can provide guidance, but we don't necessarily have anything in place for determining when and if advisory hazards should be posted. We do have a lot of information, and the Department of Health does too, that is incredibly valuable just in terms of pointing people to that. And then you had asked also about the dead fish on the East Coast. And my sense in terms of reading the fish kill reports, I haven't read reports that would indicate that they are in the state of advanced decomposition that one might expect if they had been transported from the southwest. However, the plume itself was transported from the southwest, but I think that the fish kills that we're seeing on the East Coast are probably more localized.
Thank you. Will Benson.
We heard lots of new research and study that's going on today, and I may have missed something there, but my question really is concerning with the effects of this on humans, and particularly consuming shellfish, fish, whole fish, and I was wondering if any research has been done there. Just from my basic knowledge, it's the way it affects marine animals is with the bioaccumulation of the neurotoxin, and I'm curious as to if we have pursued any research in regards to the long-term health effects that it might have on people eating fish. And I believe you said Brevis is the only one that has actually led to closed harvests of shellfish, and we have the stone crab season coming up, and looking at those maps right there, I was wondering if FWC had any plans to make a closure this year.
Okay, there was a lot there. So in terms of the fish, the toxins do not accumulate in the edible parts of the fish. However, we in the Department of Health especially advise that people do not fish in an obvious red tide, and obviously do not eat fish that have passed away due to red tide. In terms of shellfish, our commercial harvests are regulated, and so that is our partnership with the Florida Department of Agriculture and Consumer Services. And we have a very active aquaculture community, and there's ongoing testing with FX. So that's one thing for commercial shellfish species in terms of what makes it to market. That should be only harvested from open zones. And in terms of the stone crab fishery, that's a question where, to my knowledge, the toxins don't accumulate in the edible parts, but that's something where I would want to confirm that and make sure I get back to you with the appropriate information.
Follow-up question, is there any further research that's being planned by FWC, to get some answers, definitive answers?
Yeah, there's been a recent call for proposals, or a recent program that seems like the CDC will be leading to help direct some money specifically to looking at some of the human health effects. More recently, the Department of Health has been involved in spearheading an effort to try to look at the transport of the aerosolized toxins. They just started to get this monitoring network in place, but they're really interested in trying to get a better sense on in-shore infection and the extent to which those toxins can be transported. And through that, there will be some new and different ways of testing air quality. And so that's something where that project, they just put out the sensors right before, the first set of sensors right before Michael started to come through. So that's something that just started up, and we'll hear more about it, I'm sure.
Not to be nitpicky, but I want to go back to one first thing that you said in response to the questions that you put out an advisory that that neurotoxin doesn't accumulate in the edible portions of the fish. I'm just curious as to what that might be. Is that just the meat, like the fish fillet, but it does accumulate in the bones? In other words, I've never seen anything put out that says, okay, when we look at a red tide affected area and potentially eating the seafood out of that area, should we only be eating the fillets of the fish and not making fish stock out of the bones? Is there any kind of, specific concerns or knowledge that we have about, specifically what we can eat and what we can't eat out of these fish?
So in general, the fillet is the safe part, and the fish can accumulate toxins in some of the non-edible parts that are related to the digestive tract and the metabolism of the toxins. To my knowledge, it wouldn't accumulate in bones. And I am not aware personally of any research that's been done on that, but I can check and see. Specifically on that particular part. And again, the Department of Health has guidelines, and so I want people to use their resources in particular for guidance with this.
Okay.
Yes, Kate, I believe within the general public there's those who struggle to try to differentiate entirely between the algal bloom, the red tide, some of the green sludge up on the East Coast. I believe people want to know more and want to understand it better. I believe they get tied up into some of the science, and there's a lot of misinformation that comes out as a result of not knowing. Is there a source or sources that we could refer to, lead people to, that would allow them to maybe, I don't necessarily mean dumb it down, but to speak in a more layman term as to what these things are so that they can grasp it and then potentially get behind some effort?
Yeah, that's a good question. And there have been some good resources out there. I think that in terms of the agencies at the state level that are most involved, the resources that we have for red tide are valuable, and I think they have a lot of information. Both DEP, DEP also has information, but they're more specific to the freshwater cyanobacteria or blue-green algae. And then DOH has information on both. In terms of some schematics that are appropriate that kind of simplify it, that's something where I can, I'm hoping to get some help here with following up with people afterwards. But there are a few online that I can point you to that just sort of describe their different ecologies and the different causes and some of the different dynamics that are involved with the blooms that are help really explain how different they are. But you're right, there are a lot of pictures that have bright green algal blooms when the tide was red tide. And not that red tide always looks red, but it was still, that was a big struggle this year in terms of communication about these events. But there are some good resources that we can point to.
And Kate, we're going to have one more question from Jerry Lawrence.
Yeah, Kate. What I want to go back to when you were talking about the blooms in Florida Bay, and the last one you talked about was in 2013. Do you have any information about the bloom that occurred after Hurricane Irma and is pretty much ongoing today?
I do not have a lot of information about blooms. So there was a bloom that occurred in 2016. We had a wet winter, and then that quickly turned into a dry summer. And so we started monitoring, and we were able to catch the onset of a bloom in summer 2016, and that did extend into 2017. In terms of monitoring after Hurricane Irma, we've had some limited monitoring there, but I don't think that we've seen the level of bloom that we saw previously. I could be mistaken, but that's my general sense.
Yeah, it's interesting. I was just out the other day just checking it out, and it does look like it's blowing up again, and it looks like it's blowing up pretty rapidly. But I was just curious, I'm understanding that you guys are extraordinarily busy on the east and west coast. I was curious as to whether that was being monitored or not.
Okay, thank you very much for your time. And I do want to remind the public and of course all the sanctuary members that there was a lot of information in that last presentation, a lot of website links, things of that nature. All of the presentations that we have during the SAC meetings are posted on the sanctuary page at floridakeys.no.gov. So if anybody wants to go back later, download the presentations and kind of look at that a little bit in more detail. And of course, we upload the video a day or two after the meeting so you can watch this as well. We're going to go ahead and take a break for lunch. Guys, please be back here at 1:30 for a presentation and potential action item related to the Everglades restoration efforts. Thank you very much.
It's rolling.
Oh, okay.
Hey, John.
Okay, well, we're almost all back from lunch, but we're going to go ahead and get started here. We're already a couple minutes late. We're going to have a presentation now regarding Everglades restoration from Carolyn McLaughlin and our own Jerry Lawrence. Thank you very much. That's right.
Oh, thank you. Thank you for allowing us the time. Carolyn and I are going to do kind of a tag team. I'm going to review some of the history of Florida-based problems that lead up to where we are today with some of the restoration projects finally coming online. And I'm going to turn it over to Carolyn. Oh, yeah. Excuse me.
Thank you.
Where do I point this?
Is it not working?
Is it a clicker? Here, it's not working.
This always happens.
It wasn't on. There we go. It wasn't on.
Okay, so just a refresher is that, of course, the historic Everglades started in the Kissimmee chain of lakes, and the Kissimmee River flowed into Lake Okeechobee, and then sheet flowed south with the major estuarine areas being the mouth of the Shark River Slough and Taylor Slough emptying into Florida Bay. And of course, over the decades, we have converted it into the system of canals and then tried to put the water back into Everglades National Park from the canals.
Thank you.
I can't do anything.
Sorry.
So the way water enters Florida Bay is a little more complex than just saying it flows out. Is that at the level of the Tamiami Trail, up at the top there, Shark River Slough, and northeastern Shark River Slough, about 20 kilometers across, and then they kind of get pinched between the Big Cypress Ridge and an upland called the Rocky Glades. And because it shrinks down to about 7 kilometers, the water kind of ponds in northeastern Shark Slough. And when it reaches a certain elevation, it spills across the Rocky Glades into the headwaters basin and then south through Taylor Slough and into Florida Bay. What we've got now, this series of pumps in green in the blue canals is the South Dade Conveyance System. And the South Dade Conveyance System was completed in 1984. And basically what it does is I showed the previous slide, routes the water kind of around out of the Everglades, down south, and then tries to put it back into Everglades National Park and send it south through Taylor Slough. Just to give you an example of the change that occurred in the 1982 to 84, this is what the canal system looked like. That's how big it was prior to 1982. This is what they made it in 1984. They put this great big pump house. That's the S331 pump house. It can move 1,250 cubic feet per second. So this became a purely managed system.
Oh gosh.
Blue screen, yeah, that's not good.
This is just the after lunch.
See, the computer is still on.
I know, it's the boards. I don't know why.
Well, just tell us what you think it'd be.
I can't
remember. As you can see,
don't do hand puppets or something.
I honestly, if I knew what the next slide was, I'd talk about it. I can't remember.
Okay.
There you go.
No, but I don't know what I did. Okay.
Try the next slide.
Let's all go back to lunch.
Great.
You may, I don't know why it's not doing
Should I just use it this way?
Yeah.
Okay.
Sorry. I'll try and make it as big as possible.
So that's where I was, talking about the pumps. And my colleague, Frank Marshall, and his colleagues published a paper about 5 or 6 years ago that used paleoecological studies in Florida Bay to demonstrate that right now Taylor Slough is only providing about a quarter of the water that it did historically before these changes were made. So Florida Bay is only getting about a quarter of the water that it should. And the way the system used to work, like I said, is water would come through Taylor Slough and it would exit the slough in this part of the bay, and this northeastern basin acted as kind of a reservoir, as a buffer. So water would fresh water would get stored in there, become a low salinity environment, and that would act as a buffer throughout the dry season, the oncoming dry season. Well, now the way this works is that because Everglades National Park, Taylor Slough, the water levels are higher than the canal system to the east, and the reason that is because there are farms in urban areas. Water literally flows out of the slough into the canal system, gets dumped along the eastern edge here along the highway, and literally bypasses Florida Bay. And so we end up with much more salty conditions in Florida Bay than there were historically. Just an example of what that means ecologically is these lines just represent the area of mangrove dominance from various studies done. And basically it's 1948, 67, 77, and 94. And this just shows that the mangroves are moving inland, and they've gone well beyond this point by now. It it's possible that some of this could be due to sea level rise, but it happened so quickly that there's good documentation it's a result of lack of freshwater flow. So the ecological collapse of Florida Bay began in 1987. I started working in Florida Bay in 1989. I was fortunate enough to start and still be able to see the bay in a more or less pristine condition. And within 6 months, I was watching huge amounts of seagrass die off. So this is the period from 1984 when the canal system went in. This is 1992. This is just the annual rainfall. And you can see we had this below average rainfall. We really had a prolonged drought. And so not only were we not getting the freshwater flow, we were not getting any rainfall either. And the end result is this is the salinity beginning in 1989. We didn't have the technology to measure daily salinity prior to that. But you can see these hypersaline events where 35 is seawater, and for 3 consecutive years we had much, much higher salinities than at seawater. And this is at a place called Taylor Slough. I meant to point that out in one of the previous slides, but see if I can't go back. There it was. This is Taylor River. So a lot of what I'm going to show you is data from that Taylor River hydro station, including that. And so in 1987, we started seeing these massive areas of seagrass die off. And that's what these crosshatched areas are. And actually, Jim covered a lot of this morning. Jim was co-author on this paper. And it just shows, this is, I think that might be Jim. One of these two people might be Jim. You know, they were measuring the seagrass and documenting that it wanted to decline. And that happened from 87 through about 1990. And Jim's advisor is quoted here on the front page of the Miami Herald, Tuesday, August 11, 1992. Florida Bay is falling apart like a rotted piece of cloth. So this was making not only regional press, but national press as well. And then, of course, 2 weeks later, we got hit by Hurricane Andrew, which impacted, you know, we didn't take a direct hit, but it heavily influenced Florida Bay. And then more of these types of things came out. This is, again, from the Miami Herald, and it shows these large algal blooms up against the Keys. This area was known as the dead zone because there were no fish living in it. The fishermen were having a real problem making a living during this period. And ultimately, massive fish kills. And this is not red tide. This was just dissolved oxygen in the water. The algae were taking all the oxygen out of the water and it's killing the fish. And then, of course, following that, we did have these algal blooms. And I just want to give you this example. This isn't from that same time period. This is from 2007. But this is where the sanctuary comes in, is what happens in Florida Bay doesn't stay in Florida Bay. And so this, even though this originated up in the northeastern part of the bay, it spread all the way out onto the reef tract. And this was August 18th, 2007. This is the 16th. And it just shows that, you know, here's Alligator Reef, but when you zoom in on it, you can see this cloud of green water just flowing over the top of the reef. And of course, this could have impacts. This is just an example. This is Carriageford, 1960, 1989. I use this just to demonstrate that the reefs are being impacted by what goes on in Florida Bay. Another problem was the sponge mortality. This is a picture of a loggerhead sponge, and this is taken a couple weeks later after the algal bloom came in. So, you know, this is really detrimental. There are things dependent on those sponges. Our 3 largest commercial harvests are stone crab, pink shrimp, and lobster, and of course the juveniles of those that use sponges as habitat as well. So after all this had happened, I went back and started looking at the changes in many of the vertebrate populations, and I published this in 2014. And you're not expected to be able to read this. It's just, in this column is a list of all the vertebrate species that have been scientifically documented to have been in decline in Florida Bay since the South Dade Conveyance system came online. And what these are is the American crocodile, diamondback terrapin. There were declines in bottlenose dolphin and West Indian manatee use. 5 different bird species. I only got 4 pictured here. Believe it or not, the guy who studies roseate spoonbills forgot to put one up here. But spoonbills are one of them. A great white heron, osprey, brown pelican, and bald eagle. And we documented as well declines in the prey-based fish community. Big declines. And without the prey-based course, you don't have the game fish, and so multiple species were documented to have gone in decline. So they just pictured snook and redfish here, but many others. This got a lot of attention, and the state decided we got to put in these laws that allow the estuaries to get the water that they need. And these are called minimum flows and levels. And the one for Florida Bay was established in 2006. And this is a little bit complex, but an exceedance is where occurs when a 30-day running average of salinity exceeds 30 PSU for any time period. But a violation occurs when that happens more than 2 years in a row out of every 10 years. So basically, you got to have 2 consecutive years twice in a 10-year period to make a violation. And that's exactly what happened. Is we got, this is 2006 to 2016. There's the first violation, 2008, 2009, and then here's the second violation in 2014 and 2015. So the bay is really stressed at this point. It's not obviously not getting enough fresh water, even by legal standards. And subsequently, this is from Everglades National Park, and it just shows seagrass die-off once again. This is occurring in 2015-16. The red is an area that's highly affected. The yellow is partially affected, and the green is healthy. And that's almost in the exact same place it was in the 87 to 89 die-off. And that's what it looked like. So that's Pete Frezza just out on his boat in massive quantities of seagrass now floating around in the bay. And then Hurricane Irma. And Hurricane Irma didn't just stir things up and drop a lot of rain, but it deposited these vast amount of seagrasses into the bay from the Gulf and from the Atlantic. And just to give you an example of the sheer scope of it, this is a picture of one of my colleagues on Sandy Key. She has dug down to the beach in the rack line. And that's the way all of Cape Sable looked, that's the way all of Sandy Key looked. And of course, we know that this this was not just the seagrass die-off in Florida Bay, it came from outside. In my hand here, I'm holding in my left hand Thalassia, which is basically what covers all of Florida Bay, and then these are various seagrasses, mostly Cerasodium, and so we know that those probably did not come from in Florida Bay. They grow there, but not that much. And then subsequently to that, we got a 2018 algal bloom. This is why I was asking questions earlier. And unscientifically, on Saturday evening, I went out and just ran around the bay looking at the water, and basically everything beyond the first set of banks from the Atlantic Ocean, these are tidally flushed by the Atlantic, pretty much everything north is looking like it has a bloom right now. So how does this cycle end? Well, we must restore freshwater flow to Taylor Slough and Florida Bay to avoid hypersaline conditions. The good news is that for 25 years, Everglades restoration efforts have been slowly but steadily putting infrastructure into place at the cost of approximately $1 billion to taxpayers. These projects are, the red is the Modified Water Deliveries project, and that includes actually putting the bridges on Tamiami Trail. So the idea here is to flow the water under the trail, and then these projects, this is the C-111 South Day project in blue, and yellow is the C-111 Spreader Canal project. Those are designed to keep that water that flows under the trail in the park. And what we're going to be talking about now is the powers that be are developing a plan to operate these things for maximum restoration. And with that, I'm going to turn it over to Carolyn.
So collectively, these projects, the Modified Waters Delivery Project, ModWater, C-111, South Dade and C-111 Spider Canal projects, we call them the Southern Everglades projects collectively, because you have to kind of deep-walk some of this so people can understand it. So the Southern Everglades projects, as Jerry was saying, these projects started construction over 30 years ago and took about $1 billion of taxpayer money invested into these projects to complete. And so that's not $1 billion for all of Everglades restoration, that's $1 billion just for these projects. And the purpose of these projects is Everglades restoration. It's ecosystem benefits to Everglades National Park and Florida Bay. So what's happening right now is you have a federal-state partnership, right? So on the federal side, you have the U.S. Army Corps of Engineers, and on the state side, you have the South Florida Water Management District. And so these two agencies are co-responsible for managing Everglades restoration projects. So right now, the two agencies are sitting down and they're going to figure out how are we going to operate these projects. And so how much water are we going to flow, when are we going to flow it, where are we going to put it. And so right now what we're seeing is kind of the culmination of 30 years of putting these projects together. And this is going to determine how effective they're going to be. It's going to determine their impact on Florida Bay and what kind of benefits you see not only in Florida Bay, but throughout the rest of the Keys. Just how do I?
Oh, I'm sorry.
Oh, no, it's okay. Go to the next. So this process is, they're developing a combined operational plan, COP for short. And so what they're doing is developing a series of different alternatives that they're going to model that's going to determine how to operate these projects. We saw some of the proposed alternatives that came out in August. Our concern is that the alternatives that we saw do not do enough to help Florida Bay. They do not do enough for the Keys. They don't do enough for Everglades National Park. And so a number of Everglades kind of advocates got together, we put our own alternative together, proposed it to the agencies, and then they said, thank you, but no thank you. We don't have time to model the alternative. So again, our concern is that we're not hearing enough about Florida Bay. We're not hearing enough about the Keys in this process. There were some economic studies done that looked at the impacts of this system on tomato crops, on different types of crops in South Dade agricultural fields. There was no economic analysis done for fishing, for boating, for tourism in the Keys. That has not necessarily been a consideration in this process up to this point. So our goal, and the goal of the resolution that we're going to discuss, is essentially to show that the Keys is involved in this, is engaged, and that these projects are important for people in the Florida Keys, for people with Florida Bay. And so there will be a public meeting about this process in Islamorada in December, which is great. Up to this point, most of the meetings have been either in Homestead or West Palm Beach, and that's really diminished the opportunity for people in the Keys to participate. So we pushed hard for there to be a meeting in the Keys in December. And so the resolution that we're going to look at today essentially says what we were talking about, that there is interconnectivity between the sanctuary and Florida Bay, that these projects are important for Florida Bay and the Florida Keys, and that this sanctuary supports operating these projects for ecological benefits for Florida Bay, basically. So I don't know what the process is. Oh, I'm sorry. Everyone else. Good. Yeah, that's all that I have, so I don't know if you have questions or when you want to move the resolution. How that process works. Yeah, Will?
Can you elaborate on just a little bit more what the plan that you said you guys got together and put forward? You know, what were some of the key signature things of that plan that you asked for?
Question.
Well, some of the things that we were doing is that, for example, the C-111 Spreader Canal, when they modeled it originally 15 years ago, let's say, one of the things that made that project successful was to raise the structure, there's a structure called S18C that's on the lower reach of the C-111. That was supposed to be increased by ½ a foot. And all the modeling indicated that if you didn't raise it that ½ a foot, you got very limited impact. But by raising it that ½ a foot, you kept more water in Everglades National Park to flow south. And so we asked that was, they started to do that. Agricultural said we're being flooded, even though there was no real evidence of that, and it was a heavy rainfall year. So they didn't implement that, period, at all. And it's been 6 years. It was supposed to start in 2012, and they've never done that. The second thing that comes to mind is the S197 structure is at the end of the C111 canal, and it allows water to go into southern Biscayne Bay as a point source. That was always supposed to be shut except in emergencies. Well, for the last couple of years, they've been putting as much water out that structure almost as much as they've been sending to Taylor Slough. So even though that the C111 is partially successful in keeping water in the slough, they're dumping an equal amount out to tide in Biscayne Bay. And so instead of increasing the net flow of water, we've moved the water, which is a good thing, but we've not increased it a bit. We're still dumping it to tide. And so these are the kind of things that we, a group of us that met with people at Everglades National Park and then talked to people at the Corps and the district who are doing the modeling. Those are the things that we requested that they model. And basically we were told no. And so most of the modeling effort is looking at, as Caroline said, the impact of these projects on agricultural land, and not at all to do with Florida Bay or the Florida Keys, even though that's what these projects were designed to benefit.
Thank you. Before we take any more questions, if you don't mind, we do have a resolution here. And Caroline, can I ask you to walk us through the resolution, please?
Sure.
Do you have it?
I do, yeah. So can you hear me? Is that better? Okay, sorry. Okay, and you should all have the resolution in your packets, but we just kind of started off emphasizing the connectivity again between the Florida Keys and the greater Everglades ecosystem, as Jerry pointed out. As we all know, there is a connection between what happens in Florida Bay and what happens in the Everglades and what happens down here in the Keys, and specifically the sanctuary. And so, oh, we don't have it up. Nope. Then we talk about how the sanctuary helps to protect the marine waters of the Keys and the purpose of the sanctuary, and also one of the goals of the sanctuary to coordinate the conservation and management of resources down here, not only within the sanctuary, but with additional federal, state, and other agencies as well. What else do we talk about here? We talk about Florida Bay as an important ecosystem located between the mainland and the Florida Keys. We've got 20% of Florida Bay in the boundaries of the sanctuary, 80% of the bay within the boundaries of Everglades National Park. The resolution speaks to the importance of the multi-billion-dollar fishing and ecotourism industries, recreational and commercial fishing, snorkeling, diving, etc. The sanctuary recognizes the importance of Everglades restoration and its importance to South Florida's economy, quality of life. Recognizes that chronic lack of freshwater flow, coupled with high temperatures and salinity, has contributed to seagrass die-offs, fish kills, and coral bleaching. The situation in Florida Bay is symptomatic of a larger water crisis that we're seeing not only down in the Keys, but really all over South Florida, especially this year. The investment by American taxpayers of $1 billion into the construction of these projects in the Southern Everglades. And the work of the Corps and the South Florida Water Management District to develop a combined operational plan for these projects, which will essentially determine how they will be operated in future years and their impact on Florida Bay. And there will be a workshop to discuss these alternatives in Islamorada in December. So therefore, be it resolved that the SAC, the superintendent, and the South Florida Ecosystem Restoration Task Force urges state and federal agency partners to develop an operational plan for restoration infrastructure that maximizes ecosystem benefits for Everglades National Park and Florida Bay. The final array of alternatives presented at the upcoming public meeting in Islamorada must include project alternatives that prioritize the needs of the Florida Keys community by sending high volumes of clean, fresh water to Florida Bay.
Thank you. Are there other questions? Yep, Andy?
I've got two things. Number one, I think I'd like to hear from the superintendent about this, what her thought is. And number two, I got, you mentioned there in the resolution about the $1 billion that's been expended already. Does it do me any good? I mean, sometimes I think, and I've been hearing this for the last 30 some odd years since I first heard the words Taylor Slough back in the back in the mid-'80s. I didn't know what that meant until then. But you know, sometimes I wonder that the more we mess around with things, we crop up with new problems. I'm not saying that, you know, I believe in all this, don't get me wrong, but, you know, you spend $1 billion to spend, you elevated portions of the highway there to get more water down, then the water quality's not good. I'm just, you know, I'm not a scientist, so I asked the question.
So I'm not sure exactly what the question is, but you're right.
Are we making any progress at all? If we spend $1 billion, is there any progress being made here?
Well, that's kind of the point, right? And that's why I think a lot of people are so upset when they find out about this, is that we spent $1 billion. That is not an insignificant amount of money.
No.
And these projects are not being operated right now. And what we're seeing is the chance that they are not going to be operated for what they were intended to do, for the reason that they were constructed. And so you're right, that is.
But you have the highway there is in a Canopy or the
yes.
one is elevated, so water's pushing through.
Yep, and that is in progress. They're about to complete the next stage of bridging. But these are all portions of kind of the larger comprehensive Everglades restoration plan, which is the largest ecosystem restoration plan in the world, the most costly, the most complicated. But there's a lot of things at stake. It's not necessarily just environmental restoration or the health of our national parks. I mean, we're seeing it, especially this year, we're seeing human health impacts. We're seeing fish kills up and down both of our coasts. I mean, it's flood supply, it's or flood control, water supply, sea level rise resiliency. Yes, it's expensive, but there are so many different reasons that we need to move forward with Everglades restoration beyond Florida Bay and what we're seeing here.
Superintendents.
Yeah.
Well, let me add on to what Caroline said, is that yeah, these projects take time to come online, and this is the first example of Everglades restoration where they're going to integrate some of these peripheral projects to make a real difference in whether Everglades reconstruction will work. So this is the first opportunity. Yes, it took 30 years to get here, but that's how long it took. Now is our first swing at actually taking 3 different projects, putting them together, and making them function as one.
So, Andy, in response to your question, this resolution is the voice of the Sanctuary Advisory Council. It's not meant to be my voice, so I don't want to opine on it because that's what you get to do. What I will say is that when I was in this room for the first time with all of you in August of 2018, and we went around the table, and the advisory council members at the time spoke about what their concerns were and what was important to them. I heard loud and clear that I, as a sanctuary superintendent, need to look beyond the boundaries of the Florida Keys National Marine Sanctuary. And these issues of water coming into this area from outside is of critical importance to the Florida Keys National Marine Sanctuary. I heard you loud and clear, so I think it makes a lot of sense that when our partners consider these actions, that they consider that. So that's how I'll answer your question, Amy.
Thank you.
Does anybody else have a comment or question? I have a question. So the alternatives that they're proposing now are diverting water elsewhere. They're, I guess, looking at agricultural implications and not at the greater health of our ecosystem. Is that the concern? Do we want them to put more water into Florida Bay and consider more of the impacts than just agriculture?
That is correct. That is exactly right. One of the things I meant to answer Andy's question with as well is that, you know, I showed in 1984 where they routed all that water around. All that structure was made to benefit Taylor Slough. There was a water emergency in Everglades National Park. That was supposed to be used to route water to pump it back into Taylor Slough. What it ended up doing was drawing down those farmlands so that instead of 1 crop rotation they could get every year, they're now having 3 crop rotations. So those canals are mandatorily, even though all of that infrastructure was put in place to put water in Taylor Slough, it actually took water out of Taylor Slough. And I'm afraid that that's what they're going to do with these. That is my biggest concern, is that these were constructed for restoration, period. Let's make them work.
When you say they, who is
Right now, there are so many agencies involved in Everglades restoration, but the 2 primary ones are the Corps and the district.
David Makepeace.
There you go. It may be too late to add another whereas, but leaning on some of the no economist data that we have on the financial benefits that our resources provide us and the direct and indirect impacts to getting good water quality into Florida Bay and therefore into the sanctuary. Am I talking 2 billion, 2.5 billion, something like that per year?
I think that's just fish.
You know, and the point I'm making is one of the problems you got here is we're talking environment and they're looking at dollars. And they're looking at the benefit to agriculture and the money. Well, the fact is that the amount of money represented down here, even if you just looked at the financial benefits of Florida Bay, probably outweigh the financial benefits of that farmland, but nobody ever looks at those numbers. So either in the whereases or at least in some additional stuff. And I know you have your fingers on it. If it's not in here, if I missed it, I'm sorry.
It's there.
It is in there?
It's generalized.
Yeah, there's no specific, I don't think that we have a specific dollar figure in here, but we do have a whereas referencing that.
Multi-billion-dollar fishing.
Well, if not, then on the 12th of December, that needs to be a major talking point at least. Because if you're going to talk to some of those folks, I did the governing board bios while we were talking here. And you got a couple people that I think actually get it, but the rest of them, they're farmers or they've got some kind of economic bent and they don't get it. So you got to talk to them on their terms.
Indeed, 3 of the slides that I didn't present were slides about the economy. And I always try to bring that up about how valuable Florida Bay is to the economy of South Florida. And I wouldn't be opposed to adding specifics. There was a study done by the Everglades Foundation. We might be able to glean some things in there, but I don't know. Do you still want to do that?
I don't know that it needs to be in this document, but I think it, because I think, like I said, it might be too late to the dance to add additional, more specific language. But I think it needs to show up because you might actually resonate with some of the people in the room if you talk about those numbers. I mean, it's startling when you think about the amount of money.
Hey, you haven't voted on it yet. Add it.
Along those same lines, if we're going to talk about economics and adding something, one thing that never gets talked about is the value of all of our real estate and our community down here. What happens to the prices and the value of our property when we don't have a functioning Florida Bay, we don't have fish to go fishing for, and we don't have a coral reef, right? And that's straight taxpayer dollars to the state of Florida. So there's another additional financial component to it as well of what all of us who live here in the Keys have invested in.
And then furthermore, our whole tourism economy here relies on our environment, so that's another large indicator that should be factored.
That number gets really big really quick.
I mean, can we go and just make a couple of quick changes? Is there time? Is that part of the process, or?
We can edit it now if you have the specific numbers.
I do not have the specific numbers with me.
Fine, I know there's like 6 billion. There's a couple numbers I can dig up pretty quickly. I don't want to hold up.
Can I suggest something?
Yeah.
I think if you just change one word in here or 2 words, the whereas about the Florida Bay is viable multi-billion-dollar fishing and ecotourism industry. Instead of South Florida, say Florida Keys. And there's your.
That's fine with me.
Yep, great.
Yep.
Is that Dave?
I mean, get it specific to the Keys, not just South Florida.
Sure. Yeah.
Well, why can't you include both?
Well, you could, but I think it's, Andy, we live here. It's about us.
Yeah,
as far
that
as I'm concerned.
might have been
I don't care what happens to South Florida.
You better. I'm sorry. You better. But
some real estate. Well,
Yeah, and maybe something at the very end of that about tangible real estate or property values or something like that, so that
Tangible, taxable.
tangible, taxable.
And you can put it right there. Just add it right in there before the end.
susceptible properties?
In Monroe County.
I was going to suggest
That's what
not to leave.
But
Well, they talked to that.
There are at least 2 representatives on the governing board from South Florida. Oh, I'm sorry, you didn't realize you're still.
sorry, I apologize.
No, it's me. Anyway, I don't know that I'd discard South Florida, but maybe emphasize Florida Keys and South Florida, because I also looked in that list, and there are at least 2 of those representatives from South Florida, and
Including the chairman.
right. And one of these deals is what you really got to do is count to 5. There are 9 members. You got to count to 5.
Gotta have 5 votes.
So put the Florida Keys first and South Florida second?
Either way, just include to both the Florida Keys and South Florida, or South Florida and the Keys. I think either way.
Or you can put it in, whereas the health of the Florida Bay is vital to South Florida and the multi-billion-dollar, and put the Keys second with the dollar amount attached to the Keys, and South Florida just separate.
He does it for a living.
Well, sort of, yeah. I would encourage putting the word, where it says under other related businesses, I would really use the word tourism. It's a big buzzword in South Florida and the Florida Keys and the rest of the state.
So maybe we do rentals, tourism,
I think you're right. You're right there. ISM, hyphen, you're there.
Okay.
Right, and then Andy, also in the very first sentence, it says the multi-billion-dollar fishing and ecotourism. It's really just tourism.
Yeah, I agree with you.
Ecotourism is a subset
It's
of
just
tourism.
yeah.
So just maybe get rid of the eco.
Yeah,
and
put it
the
twice.
tourism at the top.
Yep.
They say you have to tell people things 3 times, so.
No, I'm
just
here.
put it in there one more time.
There you go. That's good.
I make a motion to approve this as edited.
Second.
Thank you. If you don't mind, guys, we're past the public comment time. Before we take the vote, maybe we should take a quick moment for public comment in case anybody else has some concerns about what we're talking about here and possibly taking action on. So obviously, public comment is an important aspect of the advisory council meetings and our process. This is one mechanism for hearing from the people and various constituents about issues of interest. Public comment is not a time for dialogue and discourse with members. While we welcome that, this allotted public comment time is for us to hear from you. We have 6 public commenters. Each of you will have 3 minutes, please. And if you could come to the front of the room, grab the microphone, and state your name and your affiliation if you're within an organization. So our first one will be Bill Kelly. Oh, Bill, are you looking?
Not here.
No, okay. Curtis Crew. McKenna Anderson. Thank you, McKenna.
Hello, my name is McKenna Anderson, and I am affiliated with the Rosenstiel School of Marine and Atmospheric Science, as well as Moat Marine Lab and Florida Sea-Based Britain Environmental Center. I actually wanted to take this comment opportunity to spread awareness about a project I am working on, as well as gather participant support for a citizen science aspect. A little bit of background. I'm a graduate student at the Rosenstiel School of Marine and Atmospheric Science, and I partnered with Kim Hull at Moat Marine Lab, and we have just established the first spotted eagle ray project here in the Keys. As most of you may know, they are listed as near threatened on the IUCN Red List, and they have been a population decline for about the last 10 years. And the Moat has done research in the Mexican Caribbean, in the Gulf of Mexico, near Sarasota, as well as in Cuba, and they have used photo identification successfully to identify unique individuals and get information on their movement and site fidelity information. And we're starting that here, as well as a citizen science project where I'm just here to, let you guys know that this is now happening. I have some project cards that I've placed on the table outside So if you are spend a lot of time in the water, or know people who do, or just happen to see anything, you can report it on the website listed on the card, which is www.vote/eagleray or vote.org/eagleray, which again is on the card out there. But yeah, it's really exciting to get this started. I'm affiliated with Britain Environmental Center. I was a marine STEM educator where I also taught about conservation, and we go out on the water about 2 or 3 times a week, but I can only do so much as one person, so just here to reach out and hopefully get information from everybody. And with the sightings data, we don't really know anything about the population dynamics down here. So then I'll be using, once I get enough data points to make it statistically feasible or reliable, then I'll be using GIS to look at spatial temporal data as well as what benthic habitat they'd like to use. Surprisingly, even though they're really adorable, not much is known about them and people don't really research them here. That's just surprising. So yeah, I just wanted to spread the word about that, and hopefully I have more information on later dates to give you guys as well. But just getting started now, so it's just me, so I'd just like to reach out and ask you guys for help if you could. So thank you. Thanks for your time.
Thank you, McKenna. Next up is Gary Jennings.
Thank you. Gary Jennings with the American Sport Fishing Association. I just had a couple of things I wanted to fill you guys in on that we've been working on. Last meeting, limited entry was brought up, and I just wanted to let you know that after reviewing the scoping comments, the South Atlantic Fisheries Management Council voted not to move forward with that limited entry in the snapper grouper fishery or make any changes to the for hire permit. About 2 weeks ago, I attended the Lionfish Summit that FWC put on. I see some faces that were there. Of course, John Hunt was there and Rachel was there. It was super interesting. We helped to sponsor that along with the Fish and Wildlife Foundation of Florida. And pretty amazing things I didn't know about lionfish came out of that. And last but not least, Keep Florida Fishing and the American Sport Fishing Association have been trying to make an effort to let folks know that the Keys is alive and well. Fishing is great. There's hotels open. There's places to go. There's places to stay. And so to do that, we've put together a couple of real short videos that we send out to our Keep America Fishing folks. We've got about 800,000 people that list goes out to. And then we also provide the video to Visit Florida and other agencies that want to promote it. So Beth, why don't you go ahead and let's do the family-oriented one if we could first. This just came out. See if the volume will go up.
I'm trying. Oh, it's up.
Okay.
Thanks for using our hashtag.
Absolutely. So that one was more of the family-oriented one, and then we also did one for kind of the hardcore fishermen, and we'll show that one real quick too. You're having a rough afternoon, right?
Yep. We'll watch it like this.
So you guys were mentioning before, economics is important. We know economics is important not only to the guides, but to the hotels, the tackle shops, the restaurants, and we're trying to do our part to make sure that people know the keys are open, they're ready for business, and you can come down and visit. So just want to share that with you. Thank you. Thanks.
Gary, appreciate that very much. Thank you.
Yeah.
Thank you.
Trip Akma?
He's gone. He gave his time to me.
Okay.
So we're good.
All right, and then last then would be CC Ward.
The timing of that is really funny because that's my family's business for 45 years. And the people in there, Rush Maltz, he's my cousin's cousin. Luke Kelly and I, we went to grade school together, and we all grew up on the same street with Will Benson. We are from here. This is our home. So you're listening to the residents of the Keys, the people that really, really care. And unfortunately, that's not the reason I'm here. I am here as the owner of a hotel and a bar. But we've recently started a nonprofit. It's We the Island. Speaking for us, the people who really, really love this place. And we're worried. We're very worried. So I started paying attention to red tide 2 months ago because I realized how the toxins work. All the questions that Lily was raising, we are studying them, and I'm trying to reach out and find the questions that we all have now. So the way the toxins work is they accumulate in bivalves, so they can work their way up the food chain. In this way, mayfish fleeing a red tide bloom can affect a much broader area than just the red tide bloom. That's why I started paying attention 2 months ago. So on October 1st is the first time that the red tide went around Florida Keys from the west coast to the east coast. And October 6th was the first dead dolphin, right there at 5 Mile Creek. So I've been very, very hesitant, because I don't want to cry wolf, and I haven't wanted to use scare tactics to get people interested. But finally, yesterday, I heard back from the Marine Mammal Health and Stranding Response Program, part of NOAA, and I had some very specific questions about this dead dolphin, because obviously that's a sign of some not so awesome things to come. None of us have ever seen a dead dolphin in that area. I'm sure someone has, but no one I know. And I specifically asked, so they didn't know if it was a stillborn dolphin or a baby dolphin, and I specifically asked if a pregnant dolphin were exposed to the brototoxins created by the red tide organism, Corynea brevis, would those toxins necessarily show up in the fetus? The answer was, I don't know. And this is from Blair Mays from NOAA. So then, if it were a calf and not a stillborn, I asked, is it possible that the toxins could affect the mother without being present in the calf? The answer, yes. So saying it's not related, we don't know. We simply don't know. Someone was mentioning that there's a delay in the information provided by FWC. So as of right now, the most current report is from October 11th. Today is October 16th. In the time from this morning to lunch, the little yellow dot appeared at Port Zachary Taylor Beach. So since we've been here today, I was with my 10-year-old stepdaughter and my 6-year-old cousin yesterday at that water park, which is where a lot of Key West local children go and play. So those are beautiful pictures. It's awesome. but there are going to be a lot of really, really upset tourists coming down here being told, no, we don't have red tide. We saw what happened on the Southwest Coast when the hotels, the restaurants didn't acknowledge it and people got sick, dogs died. I care very, very much about the environmental aspect of this, but we have to be very careful on how we present this to our very valuable tourists. There are low concentrations, not only at Fort Zachary Taylor, but at Lou Key. So for everyone here, we know that those are two of the most popular tourist destinations, and we have low concentrations there. So if anyone's interested in talking to me more about any of this, my organization is We the Island. We're trying to not dumb it down, but make this information accessible to people. The really scary thing is that when I say we, I'm saying Tracy Banera, the director of health for Moat, does not know how many months the brevetoxins will stay in a mahua or pinfish. They don't have this information. So it's not, we can't just simply say it's okay.
Nobody knows around the entire state of Florida how long.
Right. So saying it's okay, what Willie was talking about with the difference between what is and is not safe to eat, there is no definitive answer saying it's okay to eat that whole fried yellowtail. Those yellowtail are being caught right off, they're in red tide waters, and who's to say that it's not stored in the eyeballs, which get whole fried with that. So the smart thing that we have to do as a community, as businesses, as the Sugarloaf Lodge, we have to say, yes, it's here. These are the possible things that could happen. These are the consequences. And just be honest. Because if we're not, we're going to really ruin our tourism and put our families and ourselves at risk. So.
Thank you, Cece. Appreciate your comments. We do have the first and the second on the floor for the resolution. Does anybody have any further edits or discussion on that? Hearing none, we'll call roll call.
Bruce Hoffman?
Yes.
Clint Barris?
Yes.
Ken Niemeyer?
Yes.
Carolyn McLaughlin?
Yes.
Mimi Stafford?
Yes.
George Garrett?
Yes.
David Makepeace?
Yes.
Elena Rodriguez?
Yes.
Jesse O'Doherty?
Yes.
George Nugent? Will Denson?
Absolutely yes.
Stephen Leopold?
Yes.
Ben Daughtry?
Yes.
Ken Rita?
Yes.
Shelley Krueger?
Yes.
Jerry Lorenz?
Yes.
Corey Malcolm?
Yes.
Andy Newman?
Affirmative.
Fantastic. Unanimous. Okay, ladies and gentlemen, I am going to hand it over to Sarah. We have a little scheduling issue that we're going to address.
Yes, so our next meeting is scheduled to be December 11th. You heard Mr. Newman mention that there is a big conference that is taking place in Florida Keys and Key Largo at that same time. And as you heard Andy Bruckner mention, there are going to be a lot of people there, including many in this room. So we have elected to move the Sanctuary Advisory Council meeting so that people can attend both events. So we will move the Sanctuary Advisory Council meeting to December 4th, the week prior. And as Bruce mentioned this morning, we'll probably continue our discussions during that session about the TEIS communications. And it's quite possible that may not be a full day meeting, but I just wanted to bring it to your attention that we've made that decision to change that so that people can attend both of those important events, the council meeting and the Reef Futures Conference. If you hadn't planned to be there, I would encourage you to consider it because I think there's going to be a lot of really wonderful information, a lot of good conversations happening. So that is what I had to say. Thank you.
And then in closing, I just wanted to mention that back on October 3rd, NOAA had a free screening of a movie documentary called The Plastic Ocean, and they showed that at the Eco Discovery Center in Key West. It was very well attended. It's a great movie. It's very moving, somewhat sad, just like most of the presentations we saw today. It is on Netflix. If you want to watch it again, it's A Plastic Ocean. But I really want to applaud NOAA's efforts to bringing this issue. There were a lot of dumbfounded people at the conclusion of that movie, and it's very moving. I encourage all of you to watch A Plastic Ocean. Yep.
Sorry, can I just add one quick thing? Thank you. We're intending to do a screening, a similar screening in both Marathon and Key Largo as well. We anticipate the date for the Key Largo screening to be December 13th. I think it's that Thursday. I'll send out a notification to everybody on the SAC, but we're hoping to do additional screenings.
Thank you very much. All right, so with that, we'll adjourn the regular SAC meeting. We'll take a 10-minute break, and then we'll here in this room, correct?
Yep.
Yeah. Okay, so in 10 minutes, we'll have our workshop, everybody. Thank you so much for attending.